morning, everybody. Announcements. Break will be at 10:15 in the lobby. I have an alarm set for 8:10 so we don't miss it because you don't want to get out there before everything's gone. That happened to someone last year at a class and it's unpleasant. Lunch will be from 10:20 to 1:20 in the, I believe that's the Girard Ballroom, AB. It's tough to read it, but it'll be in the ballroom. Just head towards the people. There's as much power as much as PyCon. There's as much power as PyCon could afford. Please share the power. There's like, I think, a few strips. So if you have a big block, try and use your extra cord. And they set up a SurveyMonkey for rating these things. This will be on again at the end. I'll talk about it more then, but please fill out the surveys because it helps me be better at what I do. It's nothing worse than sitting up here and talking to somebody for 3 hours and they hate what you're talking about. So I can always make it better, and I love the input. First thing I want to do is set some expectations. So we have like 3 hours. It's a very large topic. What I hope to help you do in this time is identify what compromises securing an API, give you some overview for some solutions, and we will go through some code and try and get through all the pieces that were in there. Last year we got 95% of the way. It just depends on how well everybody did setting up before they came. So we'll see how that goes. Did anyone not get set up before they came to PyCon? It's okay to raise your hand, because I can tell you where to go to get set up. Okay, fantastic. And did anyone not get it running and didn't email me? Awesome, so this is going to go way faster than last year. Yay, the death of Python 2.7. So what are we protecting against? When securing anything, it is super important to understand one thing above all else, and that's who are you protecting yourself against. Adversaries can be hackers, competitors, organized crime, nation states, if you're a company like me, work at a company like I do, and most often internal employees. Understanding your adversary helps you make the right decisions on determining how much security is appropriate and what steps need to be made. You can bankrupt your company trying to protect against nation states when you don't have to, right? So we may have a very complicated system because I do have to protect against nation states because I protect banks. If you have a site that has some marketing material and a form to fill in, you probably don't need to worry about nation states. So how do we provide that protection? And there's a lot of different answers, but the one answer that's always there is defense in depth. So defense in depth has been around for a long time, since before computers. One of the analogies I like to give for this is if you think of medieval castles. Medieval castles were absolutely defense in depth. They had a lot of things that you had to get through. So when you first come up, there's a gigantic wall and a moat and a drawbridge, and if you can get across the moat, then there's a portcullis, and if you can get through the portcullis, then you're basically in a small hallway where they dump hot oil and shoot arrows at you, and if you get through that, then there's another door, and then there's people, and then if you get through that, the important stuff is in the tall tower, and the reason it's in the tall tower is because there's a gigantic door to get in, and then you have to go up a single person staircase that goes up, and they can just start piling up dead bodies as you're trying to get over. So there's a lot of things as you go along the way that they've created to prevent you from getting where you need to go because there's the assumption that at least one of these things will fail. And when you're doing defense for applications and APIs, defense in depth is also there. There's a lot of things that you do to make sure that people can get there, and how many of these things depends on how important it is. If you are protecting a $10 bill, you wouldn't protect it with the amount of money necessary to create a medieval castle, right? So understanding and then figure out how much defense is necessary. So for applications, defense in depth, especially APIs, which is what we're talking about here, there are layers that I would suggest that you use. They're fairly common. The transport layer security, TLS, used to be called SSL. Most people are familiar with it. Rate limiting and replay prevention, authentication, access control, data validation, data encryption, and then logging and tracing. Logging and tracing could really go along the side because it should happen at every level. You should be logging, when people try to access your web server. And then you should be accessing what's going on with rate limiting and who's coming in and getting rate limited so that you can maybe shut them off so they don't destroy your system. But I put it at the bottom because it's had to have a place. So transport layer security used to be hard. 3 or 4 years ago, it was expensive, especially if you had a lot of internal systems you wanted to protect. Today, that's not necessarily the case due to a Linux Foundation project called Let's Encrypt. If you have a public API and you don't think you can afford, you weren't able to afford to be able to protect it before, you absolutely can now. You can get your own cert, but this is free. There's some maintenance behind it because they only last for 90 days. And you have to get a different one for every single endpoint. I think they started doing some multi-domain certs, but again, they're free, so get as many as you like. There's a tool out there as well called Qualys, SSL Labs, that'll tell you how good your protection is. And there's a lot of things that are expiring recently that are no longer good. So you should regularly be checking how good your security is with this tool. Some places, I think there's actually some scripts out there to actually run this and check it using a web scraper. It takes a little while to run the report, but just if you do this regularly, or if you have some other tool that you can use to make sure that you're doing well with the headers that you're setting and the level of TLS you're using, this will be a super big help. It just makes sure you're not vulnerable to anything that's known out there, because there are a lot of known vulnerabilities. If you have TLS 1.0 or 1.1 turned on, there's a known vulnerability. If you have RC4 turned on, known vulnerability. If you're using some of the different ciphers, they're not great because they do have problems. If someone's listening to your network, they can find out terrible, terrible things like your keys and guess your secrets. So always be checking this. It's a living thing, right? It's not something you check it once and you're good forever. It's constantly changing, and new vulnerabilities are showing up on a regular basis. So rate limiting and replay prevention. So it's exactly what the phrase implies. You limit the number of calls that a particular user can make to your API, or users, period. Because what you're trying to do is you're trying to prevent somebody from using up all the resources on your site and creating denial of service attacks. So replay prevention requires unique requests, and that is the more difficult part of it, is that you have to have a way to identify that this is a unique request, because oftentimes that's your request, right? So if I'm doing a get to an endpoint, there's nothing unique about that. And what you'll find is most HTTP requests are very similar. They have just a couple things that are different. So there's a few things you can do with that, and one of the things that you end up having to find out is a way to create uniqueness. So there's some different strategies to do that by adding nonces. That's the big one. A nonce is something a number that can only be used once. There are different strategies for doing this, but somehow you're gonna have to create that uniqueness. This one is you can just add a header called X nonce to the header so that it's different. But when you want to do replay prevention, you're going to have to find some way to determine that this is a unique request. You can do that through some of the auth methods as well. They provide unique IDs. You're going to have to store that unique value in a data store so you can verify you don't see it again. It's very important. I see this once, I don't want to see it again. The easiest way to do that is using some sort of cache solution, something that supports like a memcache interface, where it has an add method. An add method makes sure that if I'm going to add this to the key store, and when you try and add it, if it exists, it will return an error. And that prevents race conditions. What you don't want to do is you don't want to go do a get and say, hey, have I seen this key before? Oh, I have seen it. Great. I'm going to error. No, I'm going to create it. And the time it took you to make that decision, you've also gotten 1,000 other requests from somebody who's doing simultaneous hits. You want to prevent that as much as you can. So this may be a little difficult to see in the back, but you'll be seeing it in the code examples, so don't worry about it. And here's basically checking to see if you didn't get a token, whatever you're using to identify that uniqueness, you raise an error. Otherwise, you do a cache add, hash of something. whether that's the headers of your request or some value that you're going to be able to determine is unique. And then if it is, you throw an invalid request exception. Pretty easy to do. You can do this with relational databases. I don't suggest it. Relational databases are rarely ready for the kind of volume that you need to be able to do this kind of prevention, and you're most likely going to take them down before your web server goes down. But if you need to, you can. You just need to insert a row with a unique index for that key, however that works for you. Rate limiting requires unique identifier for restriction as well. And rate limiting also requires that usually rate limiting is based on time. So one way that you can do that is by taking the information that you need to create this uniqueness. So often when you're doing rate limiting, it's per account. So you're allowed to make 10 of these a minute or 100 of these a second, whatever that case may be. And so the way that you do that is you find their identifier for an account or a user. You find an identifier for the action that they're taking. And that could be just a standard name that you're going to be rate limiting, or you could use something like a combination of the method and the URI and a piece of time. So it's super important. It doesn't have to be, doesn't have to look like time, but you're also going to do a time segment, because you're going to say that, oh, you can only do this one time per minute, one time per hour, one time per second, and you have to have that slice there. So one of the things I don't recommend is that you worry about an exact time. So if you're from the time you make the first one to the time you make the 10th one, you don't want to track that time, because that's expensive. Because you're going to have to basically stick a bunch of things in with timings and then count them all. That's really expensive, because that can go across multiple things, right? So you're going to have to pull down a bunch of data, which you don't want to do because that's expensive, and then count it up, which is very expensive. What you want to do is you just want to create just a time block. So if what you're trying to do is to prevent people from being able to attack your system or abuse your system, you shouldn't worry about the exact time. Just say during a 5-minute segment. So let's say it's 5 minutes. During this 5-minute segment, you can't make more than 100. Will they be able to make more than 100 in a 5-minute time period? Yes. The maximum is 200. But if you can live with that, then you're going to be okay, because it's a much less expensive thing to do. You can create a single key to go in a key value store based on a time slice, an action, and a user. The other way is you're having to add a bunch of data into databases and getting it by everything beyond this time and then counting it all up, which is expensive and can't be done in like a Memcache store. So when you're doing these types of things, at least at a very high level to protect yourself from attacks, do that once you determine it's not somebody attacking or abusing your system terribly. If you want to check to see if they've done any more calls in your database after that, that's something you can absolutely do. But that's more of a billing and an account validation than it is protecting from an attack. So this is protecting from an attack, and you want to use as few resources as you can, because when you're trying to protect from a denial of service, the last thing you want to do is use up so many resources protecting it that you deny your users the service. Again, you want to use the add and increment functions of the cache to prevent the race conditions. Right, so just like before, you would do an add. Right, so here we're getting the time slice. We're getting a key based on the time slice. You're going to do an add of the key to say that it's 0, and then how long it should be there. Right, so when you're using cache systems, they want to know how long is this before I invalidate this piece of the cache. And then you do an increment. So caches allow for an increment. So you add it. You don't care if it fails. You're not checking to see if it succeeded or not, because if it's there already, that's good. You're just going to increment it anyway. And then you do the increment. And then it will return, the increment is an atomic thing, so when you do the increment, it returns the current value after it incremented, and you can determine if it's too high or not. You could do the same thing on an RDBMS. Again, I don't suggest this if you don't want to set up a cache system to figure this out, and the file-based caching stuff we're going to use today is a little too primitive, and you want to mess around with it, you absolutely can. But it's kind of weird on how you do it. Some databases allow update returning. Not all databases do. So data stores can be done in 3 ways. So again, you're trying to protect against resource utilization. So there's a few ways that you can do that. So one is that you can use a local memory data store. That's a little tougher to do in Python, unless you're using greenlets or something that has some sort of constantly persistent data store in memory that everything uses. Gets a little tougher, but you can do it. Let's say if you're using what I'm familiar with as MicroWSGI, is you can have static things shared across your threads. And so you can have it make sure that, as long as these threads haven't gone beyond a certain amount, I can look in memory because it's very cheap, right? I can very quickly just increment a value inside of that and see if it's too high for my key value, doing that in some sort of dictionary. The problem that comes with the in-memory data store is you don't want to have it use up all of your memory with everything of everybody going into it. So if you have a super, super high volume system, in-memory data store is probably what you want to use. If you don't have a super high volume system, you probably don't have to figure it out. So local data store. So if you have a server and you can locally run something like Memcache or one piece of a large scaled caching solution, Memcache is super cheap as far as memory and utilization, so that's something that you can use. You can also, if you're doing containers, right, you can always sidecar on something else that's some sort of caching system into a container. That's a really nice new thing that everybody's doing with containers. And that's going to prevent you from using up network resources, right? So the local data store, the memory data store is preventing from using as few CPU resources and server resources as possible. A local data store is preventing you from just using up all of your network. And then a global data store is something that's going to make sure that be able to track it across multiple instances of your servers. Right, so if you're running a real-time API that has uptime needs, then it's absolutely going to have at least 2, hopefully 3 instances, maybe more, maybe hundreds, maybe thousands. You'll need to share that global data store to be able to prevent it along the way. To make sure that as the things are being spread across all of your servers, you don't have someone who's just sending out just millions of requests to all of your servers, because that's what people do on a DDoS attack. As defense in depth, right, depending on where your needs come, you start with a global data store, a local data store is something you add on top, and then a memory data store if you have a high resource utilization system. And with the things that we're going to show today, you can actually just make one that checks all 3, make sure that locally it's fine, and then you can check on down to make sure things are getting incremented. But the important thing is that you want to make sure that people aren't just trying to destroy your system with replay attacks. So authentication, most of us are probably reasonably familiar with that, at least that it exists. One of the things I've seen more in the SOAP world than I have in the XML world than I have in the JSON world, please don't make authentication part of your body. Yeah, question? Sure, ask questions.
I'm new to cybersecurity, and I wonder whether I understood it correctly. So you, with replay attacks, you suggest to record all the requests in the database to make sure they're unique, or am I getting it wrong?
So the question is, for the replay attacks, are we talking about recording all the requests in a database? No. What you want to do is you want to find what creates uniqueness. So when we're talking about, that's fine. When we're talking about user rate limiting, right? You're going to create that this user can only make this many requests in a particular amount of time. When you're talking about, replay attacks, you're checking to see if this has ever been used before. Whatever is unique about your request, you're putting one record in there that's going to, and again, if you're using something like Memcache, it's just going to fall off at the end. So you're not going to use up all of your resources. You're just going to stick it in there and say, have I ever seen this before? If I have, I've seen this. This is a replay attack because I've seen this request before.
Right, so you stored that per user, right?
So this one is for replay attack. This is unique to the request to make sure that someone doesn't. So and let me explain why this is important. So today I can go and there's software out there that I can get that's used for testing. I use it locally for testing. To see how many requests per minute your system can withstand. if I don't have to do anything different for a request, it costs me nothing to do that. I can just have it play the exact same request over and over again, split out to thousands of threads across hundreds of VMs, and have it just do a massive volumetric attack because it costs me nothing except for network resource and a tiny bit of memory for each thread. If I have to generate a unique identifier for every request, that's expensive because I have to use CPU to generate that unique value. And it has to be unique so that I don't let you know that this is a volumetric attack coming at you. So you're trying to always make it more expensive for the attacker. So all of these solutions, the defensive depth, right? You're trying to make it more expensive for them to attack you. And hopefully you get to a point where the amount it costs them to do it is way, way more than the value they'll get from whatever they get from attacking you. So, but sometimes they're not doing it for money, right? Hacktivists, if you work at a company that lives on one side of any particular issue or another, there's somebody who doesn't like you because you live on the other side. And the likelihood that if there's someone out there that wants to attack you is going to be reasonably high. And it doesn't matter who's right or wrong, they're just going to do it. Does that answer your question? Oh, no worries. It's important for me to make sure everyone understands. So the way that you use the database to do this is you're basically sticking things into, and I would just provide, don't use a database. You can use a database. Don't use a database. Very expensive. Use something like Memcache, Redis cache, some key value store that's not going to use indexing. It's going to be very quick, and it will expire. Right? It's important that when you're having these things is figure out, when you're using Memcache, it will just keep filling it up, and when it runs out of space, it drops the old ones off. Right? It figures that out. It does garbage collection. That's not a problem. When you're doing things that are time-based, once that time window has elapsed, you no longer need that value. So save some memory and tell it to expire after, if it's a 10-minute window, have it expire after 10 minutes because you don't care anymore. So, like I said, you can do it with a database. Don't do it with a database, right? If you want to make a proof of concept because that's what you have and that's all you have available, you can make it as a proof of concept. Doing the file level caching can be very expensive for people who have slow file systems. And the file level caching stuff we have in our example, if you put it in the wrong directory, it's going to crash. Right? Because it's very dumb. It just goes, oh, let me look at all the things I'm supposed to expire. Oh, there's a .ds_store file. I can't read that. I blow up. Right? It's a very dumb solution. But it's fine for our example, which is what we're going to do. But like I said, it's an expensive thing that you don't want to do. But again, if you want to make a proof of concept or something like that, you absolutely can start there. But don't use a database because you won't. The most expensive thing on most applications for time and resources is database. So you don't want to rely on the most expensive resource thing to reduce the amount of resources you're using. So next time, make sure I put in a big red, do not do this, but this is an example. Unless you have an extremely fast database, right? So we actually do use our database for caching because it's a key value store. So we use Cassandra, and Cassandra was actually easier and faster than bring up a separate system because it does everything we need it to do anyway. So again, Cassandra is a very different thing, and most of you probably aren't using Cassandra because Cassandra actually has auto expire. It has TTLs and all that kind of stuff. Okay. So modern world, not a big deal, but if you have a legacy system, right, that somebody built and went, oh, I don't understand authentication, I'm going to have them send the username and password across in the message. Don't do that. When you do that, you have to actually parse the body to determine if it's a valid user or not. Valid users are less likely to attack your system than invalid users. But so parsing the data, especially if you've got XML, there are things that you can do in XML that are known vulnerabilities for XML parsing, right? If you're using an old version of some XML libraries, an old version of Python, there are some nasty, nasty vulnerabilities in there, especially when you tell it to, you can basically create a link that says, here's my data validation for this XML, and it's going to go load stuff from a remote server. That's just part of XML. It's how it works. So you want to make sure it's a valid user first. It's a valid request first before you start parsing the body. There's also some stuff with JSON, if you make it large enough, you can do bad things to the system with buffer overruns, things like that. So you don't want to do that. You want to validate. You want to make sure it's a valid user before you start dealing with the data. Make sure it's from a trusted source before you start dealing with the actual data. So fortunately, there's an authorization header. It's part of the HTTP specification. If you're an API builder, you should be, and you're not super familiar with the HTTP specification, spend some time. It's kind of a pain. You have to learn how to read RFCs, and that's a special skill that I've had to learn, is how to read RFCs. But there is the authorization header, right? So most of the world has seen basic authentication. Basic authentication is an authorization header. The type of authorization is basic, and then you have a hash of the username : password. That's basic authentication. I don't know what, I'm assuming it's sending over the hash so that it becomes URL safe. It's base64 encoded, not hash. It's base64 encoded. Just so that you can have binary password, I guess, if you wanted to do that. It's super common, but not really secure. The password is sent across the wire. So if you're sending it across using TLS, there's a bunch of ways that you can attack TLS, man-in-the-middle attacks, things like that, people can go get that user's credentials that you don't want to do. Digest authentication, it has some really nice features, including a nonce, right? So if you need to be able to create that single request identifier, digest authentication allows for that. What it doesn't do is protect the password. So it doesn't send the password across plain text. It sends it over either MD5 or SHA-1, which anyone with a decent hashcat machine can crack in very little time. So if they were to capture that information, if it was MD5 hashed, they could recreate the hash and figure out the password in minutes. If it was SHA-1, they could do it in days, depending on how many GPUs they had. Not super hard. So bearer authentication is becoming really popular. So if you've used OAuth or OpenID, OpenID is based on, or OpenID Connect, I should say, is based on OAuth 2 with JSON Web Tokens. So bearer authentication is you're presented a token. I had to make it fit. That's actually something separated. It's 3 segments separated by periods, which is what JWT tokens look like when they are compact serialized. So these don't require passwords, right? So you're preventing credentials for a user. It's signed by the system that's presenting the tokens, by your OAuth server or your OpenID Connect server. If you've done social login, right, login with Facebook, login with Google, that's what it's doing, right? It's preventing a bearer token saying, "Hi, I'm Facebook, and I'm logging in for this user into your system, and this credential is good from this time to this time, and it's good for these systems. And here's my unique identifier for this token, so you can, if that token ever gets revoked, you can know that this token was revoked." It's becoming popular. A lot of APIs, well, not a lot. There are a few APIs that I use externally that provide OAuth authentication. There's small problems though, is it adds a level of complexity where you're going to have to go get the token and store it. If you don't do that, you have to make 2 calls every time you make an API call to go get the auth token and then to make the actual request. Otherwise you're having to store it somewhere. And in Python, most of the applications don't have a lot of places to store things that are used globally. Unlike most of the stuff I think is being used probably by JSON or by Java and .NET, where you do have that. There are some places, if you really, really wanted to, where you could stick that per server in your Green Unicorn or your MicroWhiskey server. But that's a hard process. There's not a lot of good solutions out there. The other option is to roll your own. A lot of APIs do this. Because they're trying to increase security but not add the complexity, right? Because when you make it too hard, nobody's going to want to do it. If someone has to make 2 requests to your system every time they want to do it, that's adding strain to your system. So they probably have the right reasons to do it, but you're always told never roll your own crypto. And that's for good reason. Because the people who are cryptographers who are attacking cryptography know it better than you do. Which creates a conundrum, right? And fortunately, there's some middle ground. So there's single-use JSON Web Token. So this is something that I use in all of my APIs because it's using JSON Web Tokens, which are the basis of OAuth. But it has some advantages. There's no auth service required. So you don't have to go to a separate service to get the token. The system, you're generating your own token saying, hi, I'm your user. I'm allowed to access your system. Here are my credentials saying I'm allowed to access your system, but I'm only going to use this once. You can use existing JWT libraries to create and validate those tokens. So before we were using JSON Web Tokens, we were rolling our own, which was awful. All right. If you've ever had to use the Twitter API using the old OAuth and had to add the extra headers in the right order and do all this crazy nonsense to actually create the hash, you'll understand the pain that people had trying to use our system. And it can be extended beyond auth to provide validation and man-in-the-middle protection. So JSON Web Token is just a piece of JSON that has a specific schema that's extensible. So there's things that are protected that can only be, that mean a certain thing, and anything beyond that you can use for whatever you want. So just like headers, you create an X dash header, that's totally allowable because it's extensible. JSON Web Tokens are extensible as well. Once you get beyond their standard, it's considered a private value, and you can do whatever you want. So that's what we did in our system. And we'll show this a little bit later. So access control. So access should be denied by default and programmatically enabled. Right, so make sure that's one of the things, anything with security, make sure it's off, and then you allow for exceptions. If you have firewall roles, right, by default, nobody can access except for this IP, this IP, this IP, as opposed to enable this IP, disable people who are not these IPs, right? You want to make sure that by default, you just can't get in. The same thing with access control. Most of us are probably using something built into whatever framework that we're using to do this, so it just kind of happens. But if you can, if you're not using the things that are in there, or it doesn't make sense to use the things that are in there based on how you're doing authentication, make sure it exists outside the controller logic. Right? Don't allow people to get inside of a bug. Find something outside. So if you're using some sort of middleware in front of your front controller, right? You want to make sure that you're doing that before you get into your code, so that you don't allow hackers into the juice of your code where your bugs are going to be and your vulnerabilities are going to exist. At least make sure it's somebody who's set up an account. Make it expensive for them. Data validation. So you should validate the data coming into your API. And it seems pretty straightforward. Never trust anything from anyone, ever. Even if it's your own application, never trust data from your own application. Right? Because your own application can have bugs and send things that can do terrible things to your system. And if you have something that's external, there are man-in-the-middle attacks that can happen. And I'm not just talking about data validation to the request itself, the JSON data. Validate that the request is valid in the header level. Right? Make sure that the method is allowed. Do all this validation against the system to make sure that it's what it says that it is. So, like I said, message is something the HTTP message itself, making sure that this is a valid request. And there's bad things that can happen when these things are compromised. We'll see examples of that in a second. So request data, really bad things can happen. So you take a very standard request. This can be the entire request. So you're doing a GET on a user record, right? Real standard REST stuff. But if I change that GET to a delete in the middle, bad things happen. So you want to make sure that people can't modify requests on the way through a man-in-the-middle attack, right? So that I can't modify the request, right? So let's say I get user ABC, totally valid, but in the middle I change it to a user that I want to see. I change it to user DEF. You don't want to allow that to happen. So let's say a patch request, right? Now we're talking about the body of the request. So in the body, I send it, hey, change the email for this account to the valid user, and then in my man-in-the-middle attack, I change it to my email. So now I can take over their account because I can do a reset because I have their the email address associated with my email address. So you can see just small changes to an HTTP request across the path can do just terrible things. There's also response validation. So it's not necessarily happening on your API, but the consumers of your API, if there's a man-in-the-middle attack, can have bad things happen. So you can have things, basically you can take this standard request with a 200 OK and make people think that the service isn't working, right? They'll think that I can't make proper valid requests just by changing the status code. You can basically create a denial of service situation because every client's going to blow up on a 400. It successfully worked, but the consumer doesn't know that it worked because they're constantly getting errors. One that's even worse, question? We are going to talk about how to protect against this. So I could change that to a 301 and have them get data from another system and this is an issue with requests, right? I love the request library, but built in, it automatically follows redirects, right? So be warned that if a man-in-the-middle attack comes in and says, oh, this is moved to here, they'll go get whatever you wanted them to have, which could have something that's going to use a known vulnerability against whatever system they're using. Right, so it could be something, there's a known Python attack, there's a known attack against requests, or Beautiful Soup, or the XML library, or something. The other thing is that cache control is another big one. So if there's something coming back, like I'm going to go say, is this, go get me the information for this user, and it says, great, they're active, and they're okay, and they're logged in, that's great, but I never want you to cache this, because that can change at any point, any time. And if I tell you to just store it forever, then I can deactivate my account and still keep using it because now you've cached it until your system runs out of cache. And the other thing that you can do is just modify the body, right? So I'm not a valid user, active is false, but then I just change it along the way to true. Bad things happen. So the other piece is the validation of the request library. So there are a lot of existing libraries out there to do this validation. Find the one that works best for you. My experience is don't use one. If you're using, REST, you can absolutely send form data as part of REST for the input. If you're not sending form data and you're using JSON, you can use form validators. Don't. The messages are just weird, and the way they react are funny because they're trying to create one response line as opposed to being able to give you, telling you this feels bad, that feels bad. So find one that's specific to the type of data that you're receiving. Encryption. So this is one of the more expensive things. And if you are doing business in the EU and possibly California here very soon, and maybe Washington, you're going to have to protect your users' privacy and the data that you have about that, and it may have to be encrypted. Even if you don't have payment card information, in the EU you have to encrypt PII to prevent people from being able to track users, and California is about to adopt, or at least they're trying to adopt, basically the same rules there, and so is Washington. So if you do business in the US, you may also have to follow this. So encrypt data at rest. And this is a complicated thing that I did wrong for a lot of years, right? How do I properly encrypt data at rest? And I usually do it wrong. So what I found is use a structured format that allows for in-place key rotation and non-storage. So one of the things that people do very wrong when they're doing this is you'll encrypt data and you'll just store the encrypted data in the database or in the file system. And since you're not storing the nonce with it, you're using a static initialization vector if you're using AES, right? Or using some sort of static nonce, which means it's not a nonce. If you're using what's considered to be fairly good software, right? If you're using AES GCM, which in the AES world is considered the best crypto there, and you reuse a nonce, it's completely crackable. That's bad. There are other problems with AES CBC as well if you have the same nonce, right? You can start finding, as far as, I have a whole other cryptography talk, but you can see patterns. If you don't have that nonce added in there or that random initialization vector, you can start seeing patterns and people can be more easily able to determine what your keys are just by determining what your data looks like, and you can do some heuristics against the data to determine very quickly what keys are. It's scary. If you want to be scared to death, go see someone do a talk about the CryptoPals hacking exercises and see how easy it is to hack modern cryptography. It is frightening. The other thing that you want to make sure that you can do is rotate keys. So if you were like me and even if you put a nonce in another database field, you had a single key, and then when you had to go, when we're like, oh, that key got stuck into somebody's code and it got checked in and everybody saw it, or this person quit and they had all the keys, so now we have to change the keys, you have to stop your whole system to re-encrypt your database. That's not good. So what you want to do is use some sort of structure that allows for in-place key rotation and non-storage. One way to do that is through COSE. So COSE is the CBOR object signing and encryption standard, and CBOR is the concise binary object representation. There's no Python library for this. So it may not be your best option, but there's no reason that you can't get together with a few people and try and make one during sprints, right? Yeah, question? So you would have to re-encrypt everything. Every time so the question is, wouldn't you have to re-encrypt everything if you changed your keys? Maybe. So just like passwords, right? If you're accessing it and you create a rotation window, as you're accessing data, you can determine it needs to be re-encrypted and then re-encrypt it. And then when you get past that window where it's like, okay, we've had in place go, now we're just going to encrypt the whole database. Yeah, you have to re-encrypt everything, but you don't have to stop the system. Because when you have a single key, it either works or it doesn't. So you can't have, when you change the key or when you change the data, one of them's not going to work until all the data has been changed. So if you can tell, if you store inside of your encrypted data, I'm using key number 1 or I'm using key number 2, while you're encrypting it, while you're decrypting it for key number 1 and encrypting it for key number 2, when you retrieve the data, your system can say, oh, this was encrypted with key number 1, I'll use key number 1 to decrypt it, or this is key number 2, and I'll use key number 2 to decrypt it. So you don't have to bring down your entire system for a weekend while you're re-encrypting your database. Because I've had to do that. It is painful and ugly, and everybody's angry that they're losing money. So, like I said, CBOR is probably the best way to go about it because it's using a standard, which means, again, you're going to have standard libraries. Or sorry, COSE. COSE is a standard, and it's going to get more popular, and so I bring this up because it's coming. So if you've ever heard of WebAuthn, or the Web Authorization Framework for doing multi-factor authentication on the web, it's built into all of your browsers right now. It uses COSE instead of HOSE because JSON Web Tokens are text and HTTP2 is binary. So it was built around the fact that we'll be all moving to HTTP2 soon, just like we all moved to IPv6, right? And it's cheaper to create the data binary and send it across binary so you don't have to take binary, turn it to base 64 encoding, and then convert that to binary. So it's more efficient. The other option is to roll your own. So this is what I ended up doing in our database is I store the key ID, I store the nonce, and I store the encrypted data. So mine's going into binary, so I just use nulls in between. So I have the key ID, which is binary value with a null, the nonce with a null, and the encrypted data. And then I just literally do a regular expression, split it up by the first 2 null characters. It's super simple to do, and it worked really well for us. We don't have size limitations because it's kind of a key value data store, so there's no like table width and all that type of stuff. It's possible that you could do this inside of multiple keys in your database, but if you have a bunch of data that has to be encrypted to have social security number key ID, social security number, it gets unwieldy, and it's not really stored with the data, and you have to pull it all in. Either one will work. I found that this seems to work better because DBAs don't get angry for the extra stuff they have to stick in their databases. Encrypting data in transit. This is a hard one. But relying on TLS, if you're someone who has to protect important data, is not a good idea. So it's a fantastic opening gate, but if you've been doing this for more than a few years, you'll remember Heartbleed. You'll remember Cracked. You'll remember there was a period of like a year where we had to rotate our keys and change our versions of our software every 3 months because there's a new OpenSSL vulnerability. Fortunately, there's been a lot more people providing time and resources to OpenSSL, so that's less of a problem, but most of your web servers are going to be using OpenSSL or some other variant that's open source and has vulnerabilities. Expect there to be a vulnerability. Be prepared for the fact there's going to be a vulnerability in TLS. It happens. It hasn't happened in a couple years, not a really bad one, right? But Heartbleed basically said, great, I'm going to pass this value and this data in such a way to TLS that you're going to give me back the memory at this memory location, which, by the way, is your key. So be prepared. So what we normally do in stuff like this is, what would someone else do, right? So you're like, what would Google do? What would Facebook do? What would some other company here that I trust that does things well, and at least we hope they do things well because they're a giant corporation that would lose a bunch of money if this wasn't good. And originally that's what I ended up doing, kind of going through that, and they all have some weird way of doing it, where you put the data in a particular format and do this kind of weird thing, and it's very specialized, and they don't really open source their cryptography. They just, you can use our SDKs, and you can kind of copy what they do. But one of the things I did find is that they require their own SDKs, and they usually don't allow for key rotation, right? So you have a shared secret. So if you have an Amazon account or you have a Google account and you have an API key, right? That's a single value, which is the identifier, and a single key. No key rotation, right? It works or it doesn't. If that gets compromised or you want to change it, your application doesn't work while it's being changed. It's not good. So what I use is JSON Web Encryption. So it's in the whole Jose space, which is JSON Web Tokens and JSON Web Signatures. It's an open standard that provides for multiple encryption methodologies plus key rotation. And it also has libraries in most languages, including Python. There's 2 in Python, actually, with differing results. And the nice thing about JSON Web Encryption on my side, right, is that I have customers that I want the most security possible. And I have other customers who are like, I just need something easy that works with my stuff. And if you roll your own, you don't have that option. And you have to try and figure out, well, how do I let this company use this and that company use that? Where JSON Web Encryption, there is a list of algorithms that you can use. And as an implementer, I describe which algorithms are allowed. So I say, yep, you can use AES and you can use RSA. So if you want to use RSA, that's fine. If you want to use AES, you can only use AES CBC with a SHA-256 hash. And I can specify that. And as new algorithms are added, I can just update my library or submit a pull request to the library, which is what we tend to do, to support this new thing, and then tell customers that this is now available. You can now do elliptical curve encryption. Here you go. Have fun. It's worked out really, really, really well and reduced the amount of code that we had for encryption by 95%. Because when you add encryption to your systems, you have to make sure that it works, and you have to make sure that it's working properly. And there's a lot of testing, and there's a lot of code, there's a lot of knowledge that has to happen, because you have to really understand how these things work to implement good encryption on your system, or you can just use Jose and use JSON Web Encryption. And then lastly is logging and tracing, right? So the most important thing is log everything. Log as much as your systems can allow. Because when there's a problem, you'll need to know that, right? The last thing you want is, oh wow, there's something going on, but I have no visibility into it because we turned that log off because it seemed erroneous. You don't want to have that to happen, right? When I release live systems, the first thing I do is like, okay, where could there be problems? Let's make sure we're hitting logs, we're throwing stats. Like, you have that weird case that should never happen. Well, does it ever happen? Let's find out if it happens. Let's hit a stat or write something to a log file that I can go find out that it's actually happening and trace it. and do things like that. One super important thing is log in a structured format for easier parsing. You don't want to manually parse your logs, right? grep is fantastic, but it has a lot of false positives when you're looking for things, especially if it has a common word origin. You don't want to have to look for that. What you want is you want to have structured logs in something like JSON that you can upload to some server to be able to analyze your logs. And if you're super advanced, you can actually have stuff analyzing the logs that were loaded so that you can determine if bad things happen. But importantly, log all pertinent actions. So if something's important, make sure it's being logged so you can tell if it's happening, if it's working, if it's not working. Because when it's not working, you're going to have problems. Include all data regarding the state and anonymize sensitive data. The worst problem that I've ever had in application systems is there's something wrong, but I don't know how to recreate it. Right? Somebody's managing to like open the system wide up, but I don't know what they're doing to do that. I've got to recreate the request, but I have no information to do that. So include in a problem area, right? Include all data regarding the state. Put it in your structured log. Include origin data to identify bad actors. If you're behind a firewall and you have a load balancer or you have a reverse proxy, make sure that you're allowing X forwarded for and putting that information in so that you can find out where this thing came from, or every single request from a bad actor is going to look like it came from your firewall. Make sure you're recording that origin data, the IPs, because sometimes you just might say, this IP is attacking us. They haven't made one good request, one valid request. Please disallow it on the network. Right? Sometimes that is the easiest way to get rid of a bad actor, is you just blacklist them. But if you don't know who they are and you don't know where they're coming from, you won't be able to do it. A lot of times they're coming from a proxy, right? They're coming from an onion router somewhere, some sort of proxy on the dark web. You don't want those anyway, right? Unless you have an API that's used by the dark web, and then you have a whole other problem. But most of us, we don't want things coming from proxies in the dark web. So if we start getting a bunch of people trying to if you start seeing a bunch of things in your log that say try to /wp-admin/login, right? That is someone scanning your system, and that's possibly someone attacking your system. So you might want to just find out where those are coming from and disable that IP address. Oftentimes it's coming from Amazon, though. You can utilize open tracing tools to track all the pertinent things. So open tracing is a standard out there that's being utilized. There's plugins for Flask, there's plugins for Pyramid, there's plugins for Django. To be able to send data. If you've ever used New Relic, right? It provides New Relic-y type stuff, but you can host it locally, or you can send it to third-party providers. So you can kind of take the power back, and also have some ability to not have to use a third-party API. So if you want to add extra data to Datadog or New Relic or whatever you're using, you have to use their APIs to do that. If you use open tracing, you have something that you can transport from vendor to vendor, and you can also use it internally. If you're using one of the open source systems out there that provide that. Utilize tools like Elk or Graylog to aggregate your logs. So there are systems out there. There's also Splunk. I didn't mention them here because I don't know if they're good or not. I know a lot of the IT space uses Splunk, but it's expensive, and I don't have any real experience with it. What I have used before, though, is I have used Graylog and Elk, and I currently use Elk. Right? And this is why your structured logs are so important, because if you have to try and create a parser to parse the data, and let's say you have a stack trace, right? If your stack trace is not included properly inside of a structured log, you're gonna have a separate log line for every return on that stack trace, and you're gonna have to figure out how to put those logs back together, because it's all gonna look like you have one log in your access log or error log, and it says, this file, this method, this line number. Yeah, question?
Just got to say, with Elk and Elasticsearch in general, make sure you get authentication on there.
Yes. Yes, by default, just like MongoDB, by default, no authentication. Unlike MongoDB, doesn't have it built into it, so you have to add it on externally. But use these tools, and you will find a wealth of knowledge. The other thing that we do is we just store application level logs in the same place. So, and we also use the same ID, the same request ID. So it can be important to do that. determine anomalous conditions, and alert on those conditions. So now that you have all of this data, it becomes an exercise. So what should never happen, right? And there's a lot more, like I said, you're building special applications, so you have to figure that out. But if you go to a security conference and they start talking about logging, they're going to start talking about, here are the top 10 things on a Microsoft system you should never see one after the other, because this is absolutely an attack, right? You should never see someone ask for a credential and then escalate a privilege, right? This should never happen. This is an absolute attack. So try and figure out what's an attack on your system, right? What are the things that should never happen in a particular order? And you can parse logs and determine, you can create a report to find it or some automation to run a check against it and say, hey, if I see this, I want to make sure someone knows it's going on because I have an attack going on. So this is a little more difficult and a little harder to get to, and it's a very advanced thing. But if you are like me and you have thousands of requests a minute, and you have very sensitive data, and you have very important customers who get very angry when things go wrong, this is something you need to do. And before we code, are there any questions? And we'll actually break, because it's 10:10, I believe we're supposed to break. We'll make sure everybody's set up and get started, and then we'll go break. Any questions? Question?
Going back to the encryption and rotating keys, how do you protect the keys at rest?
So that's a whole nother topic, protecting keys to rest.
I know.
Yeah. So and there's a bunch of different things. So there's vaults that you can use where you can only access the key from the memory. How you get the keys into your system is a difficult thing, and there are a bunch of different strategies that you can use, and some of them are complicated, some of them are expensive. But the important thing is that your data rests, there's separation, right? So even if you're on your API server, the database doesn't sit there. So at least there's some separation of your database lives here, and the data in it is encrypted, and there's not enough information to decrypt it. And over here is your database that doesn't have the data, but it has the keys. So at least you're creating some separation, even if you just store them on the file system where anybody can go get it. That's better than having data in your database that you think is safe because you're using a static nonce and you haven't changed, the data is 5 years old and you've never changed the keys, and 100 people have left your company with those keys, and they might have left with the data.
Wouldn't it be safe to assume that if you're dealing with that sort of compromise where your database is exposed, wouldn't also your key database be exposed?
No.
So how does your application do encryption and decryption if it doesn't have access to keys?
So the application has access to keys, but there are only certain people who have access to that application server, and they're not DBAs. So your DBAs have access to the data, and people have access through other accounts to the database, right? There are non-servers that are accessing databases more often than not, or some other application, right? Whether it's a reporting system, or you have analysts that are making hard queries, or whatever the case may be, right? What you don't want is an analyst, or a manager who has database access being able to download all of your encrypted data and then realize that, oh, this is the same key that's been used for 5 years, which means it's probably using a really bad encryption, and there's no nonce stored anywhere, so it's probably a single nonce. Let me try and break it. Because there's tools to very easily identify what type of encryption you're using, and then try and crack the key.
How does the key material get into the application if the application doesn't have access to the key?
So the API application has access to the key. The database does not.
Right, but if you compromise the application, you have access to both.
You do.
So, I mean, in most ways that I've seen the application set up is the database is only accessible by a human or by the application. And so it doesn't have external access, so your method of compromise is through the app, is not.
Correct. So what he's saying is that, for people who can't hear because it's on video, sorry. Oh, that's fine. If you have access to the key, the application server has access to the database, and it has access to the key. And you're absolutely correct. And that is the security conundrum that you have to figure out for your application. So do you have a remote key store that only stores it in memory, and you have to access it a separate way? So if you compromise the machine, there's some other information that you have to go find or have to know to be able to get the key. If you can access the memory, then you can go get it anyway. There's just no super safe way to manage that. or let me rephrase that. There's no completely safe way to manage that. There's just no way around that, which is why the most important person to protect against is your own employees, right? You want to make sure that you separate people that have access to keys, don't have access to the data, and the people who have access to data don't have access to the keys, and you create controls around that, but there's always somebody who has access to both, right? So you can never perfectly protect a system, but you can protect it as much as is reasonable. And that is the issue with security, right? Is that certain people have to have access to the data, so you have to grant them access to the data, but you have to find ways to restrict them to only the data that they need. And if you're doing it for things like the EU protections or SOC compliance or PCI, you have to make reasonable efforts, right? So that you're not liable for the information being acquired. And reasonable, there's not a lot of case law, so you have to do what is best. But that is a problem that I think everybody deals with, right? Especially if you're using containers, right? How do you put the keys inside the containers? Well, you can't put it in through memory, so it's probably in the file system, but now it's in the file system, so now it's accessible, and it's accessible where to get it from the file system before. So you're having to deal with things like vaults and key stores and accessing it through memory and APIs to pull it in, but then that adds to your latency. So there's a lot of there's pluses and minuses to every possible solution for doing that, and you just have to kind of wade through it and find whatever works for your particular system. But encrypted data with keys on an API server is way better than unencrypted data on a database that everybody has access to. So again, you're trying to increase the difficulty for access. You're trying to make it more difficult for an attack. You'll never make it perfect. And then you have to have, there's certain things you can do for that is if you try, you can do things like honeypots, right? One of my favorite things is honeypots, where you say, great, I'm going to leave these keys that are in a directory called /keys, and it'll access the database. It won't give you access to any data, but it'll access the database. And then when you do that, I'm going to know that you accessed it because it's going to tell me what IP address you were from, and I can start tracing you down because no one should ever use this to log in. Well, they're not right next to each other. Well, I mean, again, right, so oftentimes the database is in a different level, right? So your application server is touching the internet, your database server shouldn't be. Well, if you're an insider threat, the game's only over if you have access to both systems, right? So again, you're creating separation. So it's better than having both together or unencrypted. And like I said, you can create absolute protection, but will your application be usable? So there's a give and take between security and usability that happens with every application, and it happens in any system, right? You can make a system completely secure, creating air gap, right? I mean, you can make something totally secure, as long as you strip search everybody that goes in and out. You have to put them through a metal detector. You air gap it with a Faraday cage, right? There are things that you can do, but that you can't put on the internet, right? That's completely secure, but you can't put on the internet. So it's with every piece of security, the reason you add all these layers, right, is you want to make sure that you're not having ridiculous stuff out there that anybody can pwn, right? You don't want to have something that's not using TLS, not using credentials, and not using encrypted data that's moving credit card information, right? Because not too long ago, 3 or 4 years ago, you might have felt comfortable or not known better than to put your credit card information into something that's not using a TLS cert. Right? You didn't even think to look at it. Your browser didn't tell you it was a problem. Right? Now your browser will go, that's a really bad idea. You're sending very secure, sensitive information over insecure lines. So it's about making it better and making it better to a level to which you're comfortable with and your business can still survive and do what it has to do. There's no perfect solution. It's just you have to find, you have to move that dial to more secure versus usable. Because I will tell you this, that the API that I have written and architected is nearly unusable by itself. It is extremely secure and requires SDKs. Because if you did not use our SDK, you would have a hard time being able to interact with it unless you were a security expert. Right? Unless you already understood Jose, knew all about JWE, JWT, that you could create these things. I mean, having to manually create that stuff, you can't just like go into curl and interact with my API. There's just no way, it's impossible. But that's because it has to be super secure. So I've had to go through the extra layer of Great. So I have to create SDKs for everything, and every time we make a change, we have to make a change to our 3 major SDKs, right? Which means I have to have a Python developer, a Java developer, and a .NET developer. It's really fun. But like for my business, that is necessary, right? For a lot of APIs, it's not that important that you have that level. Question?
Who uses your SDKs? These are customers?
Yes, these are implementers, subscribers. So
They get the SDKs over the web?
they get the SDKs from GitHub. They're open source. Yeah, they don't do anything special or secret. They're just hard, right? It's complicated to interact with our system because it uses public-private key pairs and.
Then you have the problem of security on the SDK distribution.
No, I don't care. Anybody can get my SDKs. I mean, if your process of accessing your API needs to be secret, your API is probably not super secure, right? So our API, the documentation of our API is published. It's public, but it's just hard, right? So we make it easier by providing SDKs. You can interact 100% with the Twitter API. Have you ever tried to write a client to interact with the Twitter API? It is painful. It is unpleasant. It's the same thing with Amazon, right? You could manually interact with AWS API, but you've got to figure out how they do encryption, how they do signatures, all this stuff that they do. It's painful and hard, so they provide an SDK. So if you want things to be secure, it's going to be harder to interact with, right? You're going to have to be able to create, and we're going to do that in this class, right? You're going to have to be able to create JSON web encrypted data, and you're going to have to be able to decrypt JSON web encrypted data, which means you're going to have a library, because doing that manually you could do it manually, right? It would take you 10 minutes or so, right, to go get your key and base64 decode the data and get the structure and then pass to something to decrypt. I mean, it's a lot of work to do it. But that's one of the reasons that you write SDKs, right? So when we get to the actual coding part, right, we're going to start adding piece by piece by piece more and more stuff to make it harder. And when you get down to the last piece, hopefully we'll be able to get there. It depends on how quickly everybody goes through this stuff, right? We'll use that single-use JSON web token, which is also going to include inside of it the request data, which is the method and the path and the query parameters and a hash of the body to ensure that this header and this body go together, because that's the difficult part. When you have the header piece that's secure and a body piece that's secure, how do you know that they actually are supposed to go together? So you basically include in the signature that data. So like I said, it's a complicated thing, and that's why if you've noticed in here, there's a client.py, because at some point, it's going to be very difficult to interact with the API without a client. Question? Yes, data validation. Right. So the question here is we talked about, when I talked about in the, right, well, so what he's talking about is when I said that you could go in here and you could go change a get to a delete. And that's not allowed because you can't do a get or delete in a get method, because your application like Flask will prevent that. Well, the thing is that Flask determines what route and what to prevent based on that header data. So it knows that this is a delete request because this is your actual HTTP request. Your HTTP request used to say, get this user, and now it says, delete this user. So it can't protect you from that because it's changed to a valid verb. If your API supports delete, it's using the delete verb. And so if you change your verb from get to delete, your API doesn't know it was changed, so it can't protect you. Well, so if you take a look at REST, that is proper REST. Yes. I'll let you go in like 5 minutes. So in the way that REST works, right, is that you have an entity, right? So representative state transfer, right? So that entity, ABC, if I do a get, it gets me information. If I do a put, it replaces the data for that entity. If I get a patch, it updates the data for that entity. If I do a post, it'll create data for that entity. And if I do a delete, it will remove it. So if your API supports delete, then it's going to be deleted. And that's what you want to protect against. You also want to protect against it changing that data, right? So if guarding against the verb is not important to you, don't guard against it. For most of us, it's important. Again, only guard against what's important to your application. Find the pieces that are appropriate to guard against. So the ones I went over are the ones that we actually care about, right? Headers, caching, verbs, the method, the path, the query parameters, those types of things are the things that I worry about because those are the things that my application allows and does things differently based on what you pass me. So in your application, just determine what things in the request are important, and if they were to change, someone will be able to do bad things and prevent that from happening. So again, so back here, so you can change the path, right? So if I change that to that, I'm doing something bad too. So you need to protect the request and make sure this is what the user asked for, not that an attacker between you and your user asked for this. That's the thing that we're trying to protect. And if it's not necessary in your application to protect against it, don't worry about it. In my application, it's very important, right? I need to make sure that people aren't trying to access things they're not supposed to access. And I also need to know, like, what is this an attack or do I have a bug in my SDK? That's another important thing to know, right? Is that yes, this is not supposed to happen, but it's a valid request. So someone went through all the work to make a valid request. It's not a man-in-the-middle attack. It's a different type of attack, or it's a problem with my SDK. Because the request was valid, it validated, it hasn't been modified. It's just bad. It's not. I'm still going to return a 400, but it hasn't been modified. Question.
So with encrypting data at rest, does that effectively prevent searching or filtering based on that data?
So encrypting data at rest absolutely prevents searching or filtering based on that data. There are ways to get around that by using anonymous identifiers to map to that data. So you just create like so if you have a social security number and you need to be able to map things by social security number, you can just generate a unique token for that social security number and store that along with it so that you can say, great, we're going to match on this unique token across our data. That's a much larger topic that we can't get into in 3 hours. But there are ways, and that's a big problem, right? Searchable data, searchable encryption. That's a huge problem that scholars struggle with right now because the ones that are used aren't very good, and the ones that are good aren't well used because there's problems with creating deterministic encryption. Your best bet is to anonymize that data in a manner so that you have an anonymous token associated with real data, and then you create your links across your database using that anonymous data. So don't link by social security number, link by user ID. Right? User ID is just some random value that has no use to anyone. And if you need to search by social security number, that becomes an even greater problem. That you can sometimes, I'm not an expert and I can't even tell you how to do that right. I can tell you that just creating an MD5 is wrong. Creating a SHA-1 is bad, but there are things that you can do. And there's a lot of information out there on searching for encrypted search. It's just confusing because I don't understand it well. Any other questions? Awesome, so it's break time. And we'll meet back here. It doesn't even say how long it will be. 15 minutes? Don't feel pressured to rate it just yet. I will put the rating thing back up later, so don't feel pressured to do it before we've actually finished. It's just a good thing to stick there when we're not doing anything. Okay, so hopefully, since everyone said that they were already set up, they have cloned the repository and gotten it running. And to verify that it worked, that means their pipenv is working. They've got Python 3.6 or 3.7, which fortunately most people are moving away from 2.7. That was some problems last year. It absolutely does not work under 2.7. And so on master is where everything works. Now, people get behind, and some things are more important than others, and you may not want to do all the coding. You may just want to follow along, and that's perfectly fine as well. Let me make this a little bigger so people can see, and maybe even bigger so people can, all right, come on. Let's do this. All right. All right, can people see that in the back? A lot of extraneous information. So actually the Wi-Fi here has been really, really nice. I was not expecting that. But there are branches here for catching up. So if you fall behind or you just don't care and you want to move on to the next thing and you want to start working on that piece, we can switch to the branches. I'm going to check out start here, which is where I'm going to start from. And that is basically a minimal, the minimal stuff to start up. It has, I don't know, server. It has a minimal hello world, which doesn't do much. Just has error handling. And if you notice that there's a bunch of unused imports, they're there to make it easier so I don't have to constantly do imports. That's what'll be there at the end as well. And I'll have the code a lot more readable once I get into actually doing the coding part. There's a piece that got added, which is the ordered signal handler. One of the bugs from last year that I didn't know until I found out is that signal handlers execute in any order, regardless of when you actually register signals. So we're using Flask because Flask seems to be an easy thing for people to get up. You can have everything in a single file, although signals are going to be in separate files to make it easier to distinguish between those. Signals, if you're going, I keep talking about signal, what does that mean? So signals are basically the event bus on Flask. So you had to install signals, which was part of the pipenv, so you would have done that. And an ordered signal handler is basically just going to execute them in the order in which you register them for the request started and request finished. Because it gets problematic if it doesn't execute in the right order, you're getting these weird errors. And I couldn't create it in my box, but other people had it on theirs because their box executed them in a different order. It was really weird. But we figured out that's what it was. So we start off with the ordered signal handler so that we can have the stuff to get started. Any questions about that? Everybody was able to get it running from what they said earlier, so I'm going to take you at your word. So now, on my end, there's also, well, I'll make this bigger. Presentation mode. Okay. There's also a client, and like I was saying before, the more secure you make things, the harder they are to use more often than not. And as we go through these things using JSON web tokens and nonces and encryption and key rotation, and time-based security and encryption and signatures, it gets more and more complicated and more difficult to use. So after probably the second piece, you won't be able to use curl anymore. So what I've created is a client, and it will actually tell you everything that it's doing, so it'll look kind of like curl. If you're an API lover who likes to talk to things from the either telnet or curl, it will look familiar to you. But it's going to do all the complicated stuff in the background to talk to the server. We're not going to worry about writing a client today because that's twice as much work for no real help. So we're just going to talk about the server side. This code is all, as you all know, is on GitHub. So if you want to take a look at what it's doing, all kinds of nonsense, right? So we'll start off. Signals, when it starts off, shouldn't have all this in here. Why does it have all the data? Did I not switch over? Did I check out master? I'm going to start here. Interesting. Oh, wrong place, that's why. Sorry, this is me checking to make sure you didn't need network. That's why it's the wrong place. My bad. I thought I was all prepared for everybody. Okay, so if everyone checks out start here, you should have, yay, you have a blank, you have a blank order signal handler, which is basically just telling you that it's going to go through the signal handlers you pass to it in order. Because in Python 3.6, well, I guess lists are always ordered. These aren't dictionaries. So it's just going to go through those and execute the handlers to make sure stuff gets done in order. And then on the server side, you'll just have a simple route. You have the error handler, which is going to return JSON because it's an API, and I hate it when stuff doesn't return JSON when it's supposed to be JSON. And that's it. And again, the only thing we added to it is that we added the signal handler, and we're connecting to request started and request finished to the thing in our order signal handler. There's some extra exceptions. There's one extra exception, HTTP exception, so that you can raise an HTTP exception with a code and a message, and then the error handler will handle that and then return the proper code and a proper message. So when we're handling things inside of our middleware, so the things inside of signals will be basically middleware that happens before and after the request. It can return an error that can then raise an exception that can be caught by the error handler and return the right data, which is probably the best way to do it, especially if you're going to be, if there are certain errors you're going to encrypt and sign. In my API, I encrypt 400 so that I can give you, I know that you're a valid user. It was a valid user with valid credentials. It's just your request was bad. I can tell you why the request was bad with information I wouldn't want to tell an attacker. So one of the reasons that I do it that way. So first thing we want to do here. All right. Now, first thing we want to do is we want to do replay prevention. We talked about that, right? So replay prevention means that you have to have some way to uniquely identify the piece that you're doing. And to make this easy, since we're going to be doing this a couple different ways, we're going to do this using the authorization header. Authorization header is extensible. There are defined methods for doing authorization. And anything beyond that is open. So inside of signals, come on, go away. We're going to add a new signal. Right, and I'm going to call it the replay prevention. Oh man, if I can type today. I can't type today. So we'll call it the replay prevention signal handler. And I've created an abstract just to make sure things do what they're supposed to do. So it's going to extend the base signal handler. We're going to create an init because it's going to need cache. Let's implement the methods first. Put in some stubs for that. And we'll call it the replay, not resplay. And we'll create an init. So I'm a huge lover of dependency injection. So the things that we're going to need is we're going to need cache, right? So when we talked about replay prevention, we need cache. We need some way to store a value, a nonce, and make sure we've never seen it before. What I'm using is not typing is what I'm using. So what I'm using is the cache that used to be part of Werkzeug. If you're a Flask aficionado, Werkzeug is kind of the WSGI abstraction layer inside of there. It's no longer part of that. It's a separate piece of the Palettes project called libcache. So we're using that, and it has a bunch of different cache implementations. One of the reasons that I'm using is it has the simple cache, which is file system based. It has problems, which if you put it in a directory where there's other types of files, it will completely poop itself. So be warned. It will try and parse JSON out of a file that doesn't have JSON in it and blow up and crash your entire application. It's unpleasant. So just kind of be careful. And so we'll set right. So now we have a cache. So the way the signals work is that you get a sender, which you're not really going to use. So it might complain some stuff because in Flask request is global. Not one of my favorite things, but that's what it is. So you take your global request, and you're going to get a header. And you get authorization. There are other ways to access authorization. And spell it correctly. There are other ways to do that. But if you actually want to get just your own value for the header, this is the only way to do it. So the first thing you want to make sure is that you want to make sure that your nonce was provided. Right? So if it couldn't find the header, there's a problem. So you want to tell them that, hey, I was expecting authorization, right? Because we're all expecting authorization here because we looked for the authorization header. So we're going to raise that HTTP exception we created. And typing is not a friend of mine. And this is not because I'm nervous. This is because I can't type. Just want to make sure everyone knows that because my coworkers will see this video at one point. And if I lie, they will call me out. But I'm a horrible typer, and if it weren't for IDEs, I would not be able to have this job. Because every time I try and learn to type, it gets bad. I just get slower. And so the other thing you want to do is you want to make sure that you've never seen this token before, right? So you want to try and add it to the cache. Now, we want to make sure that this is a value that's going to be unique and that it's a string because the key is required to be a string. So if it gave you back an object, a dictionary, an array, we just want to hash it. It doesn't really matter what that value is. 'Cause it's going to be authorization, space, whatever your authorization type is, colon, and then the value. We're just going to make a hash of it so that we're not storing authorization credentials in our cache. Another important thing, don't store credentials in your cache, right? Because we don't care what they are, we just want to make sure that it's hashed, right? So, and we're going to do a SHA-512. Don't let anybody tell you that SHA-256 is faster because it's not. Not since 64-bit processors came out. So do a SHA-512 token, and we're Python 3, so we have to encode everything, right? This has been the hardest part for me for moving to Python 3. So every time you do anything crypto, it gets hard. So we're doing a SHA-512 of our UTF-8 encoded value, which we then have to get a digest of, which is, so basically SHA-512 returns an object that is a hash object, and then you have to get the digest. And then you want to actually set a value. Doesn't matter what the value is, we're putting in 1 just because. And it's angry, if not self cache add, that's correct. Oh. No, this is all correct, right? Not sure why it's angry. So basically what this is saying is I want to add a value, a key with the value of 1 to my cache. And this particular library, like memcache, returns false if it fails. And so if I can't successfully add it, that means I've seen this token before. So I want to raise another HTTP exception. And this one is going to be invalid request. You probably wouldn't tell your users this. All right, you would probably come up with something very generic, or you would come up with just a random value. When you're reporting errors to users and you don't want them to know what the error is necessarily for security reasons, but you want to be able to troubleshoot it later, you can always just create some sort of random value that you return back in there and put that in the logs so that you can look at it later. I'm not getting that deep in here. I'm just going to return a 400 error. All right. So right now, and we don't need a request finished handler because we don't do anything afterwards in our middleware. So this is our signal. And now we have to actually modify our server to use the signal, which is really simple. Move over to the server. And if you're wondering what I'm doing, I have a cheat sheet to make sure I don't screw it up, because I get ahead of myself sometimes. Okay, so again, we've got a bunch of handlers here, so all we have to do right now is just add another signal handler. So first thing we need is we created a cache, right? So we need, cache equals simple cache. And let me change to master. There we go. So we just need simple cache. That's it. And then we create our replay prevention handler. Replay prevention signal handler. And I use very long words. Equals replay prevention signal handler. And we'll import it. And it needs a cache, right? Because we said the init needed a cache. And then we just have to send it over to our signal handler. Let me get rid of that so you can actually see it. All right, so we created our signal handler, which is our replay prevention signal handler. It used cache to try and add a nonce value to cache. We instantiated it with the cache, and we're passing it to our order signal handler, which makes sure this works just like middleware, because you can't actually do middleware in Flask, which I find troublesome, but it is how they built it. And it's a Werkzeug issue, not necessarily a Flask issue. There are ways that you can do it through blueprints, I'm told, but that's a little complicated for this particular type of discussion. Any questions about that? Okay. So, first thing I will do is, since I did do this before, I will comment that out, and we'll go start our server. So, I'll actually exit from this because it's pipenv. So, is that too low? Can everybody see it? So I'm just starting a pipenv shell, and then I will do because I already have I don't have the environment variable set up. So based on the README file, you have to pass some of these things in there, which I can never remember by hand. So it's the exports for the server, which one's the Flask app, What environment are you in, and tell it to run Flask. All right, and if I were to curl localhost 5000, turn off cap locks. We get hello world, which is what we're expecting because that's all that gets returned. If I actually put in, you get headers back, everything looks good, right? So now we go and we turn on our replay prevention, and it should be angry. Once I don't know if I have to restart or not. Okay, it's fine. Restart. It's happy. It should be angry. Make sure I'm in the right code base. What's that? I did. Oh, I'm in the wrong directory again. Damn it. This is becoming problematic. So what happens when you have your code in two places? Oh, I have to do it again. So pipenv shell with the correct place. And then Flask run. And then it should be angry. Okay, yay. So, oh wow, you can't see that. My bad. So this time we got a 401 unauthorized like we were expecting. And we got our error from our error handler. So now if I provide a nonce, so if I do my curl again, and I provide a header, authorization, x nonce, authorization colon, that makes it a header, x nonce, a, I can't use more than once, right? It's happy again because I provided my authorization. But if I send the same data, it's angry again, right? Because it can only see that value once. So all I have to do is just go change the nonce value. Nonces mean they should be fairly random. This is not. But this is just to show you, as long as I give it something new, every time it's perfectly happy. All right, so if your authorization header includes something that has a nonce, like a JSON web token or digest authentication, you could just use that, hash all the data together. It gives you a nice little unique value. It all depends on what you're doing. And this is going to mess me up, so I'm going to change this now. I said this one's fairly simple. Hopefully not a whole lot of questions about, any questions about that one? Okay. Let's get in the right directory and the right shell, not flash, pipenv. So you can also do that using the client. So if I do Python client.py, and I'll use verbose. All right, so this looks very similar to what we just did. All right, it did a get HTTP 11, authorization nonce none, response 200 OK. It was OK because the nonce was sent once. I do it again, I get an error. Right, so this time I got a bad request. So yes. So the file system. So if you actually, can't remember if it's under temp by default. I don't think it's under temp because that wouldn't work. No, maybe it is. I'm honestly not 100% sure where it's storing it right now. You can go look at the code and find out where it's storing it by default, but I think it's actually storing it in temp. Sometimes it gets problematic, but this is a fresh reboot, and I don't have anything in temp that can't be parsed. That directory. Yeah. No. So what you're trying to prevent, again, so you're having to generate a nonce. Generating a truly random value is an expensive proposition, right? So what you're trying to do is you're trying to make it more expensive than just go hit this URL, spawn up 1,000, the smallest image possible on Amazon, start up a load balance tester, a load tester, and hit me with 1,000 per instance of this request every second, right? Because I can do that today, and it'll cost me about $10, right? So in $10, I can take down any system out there that doesn't have any protection. So this is protecting from that. So I can't just go do this exact same request to everything. I have to modify it, which means, and so you can't start with a file, because if you use the same file of values, that's not going to work. So you have to actually write code to produce random values in a particular place, which again is doable, but it means that the attacker has to do something. It requires them to invest where otherwise they didn't have to. So a lot of attackers will just walk away, because sometimes they're doing it just to see if they can, right? There are novice researchers out there that are just trying to see what they can do on the web, right? Trying to see if you're susceptible to this type of attack. And if they can, what can they do to your site? No, not necessarily any malicious intent, just, they just don't care. They're just trying to see what happens, and they think it's kind of cool they took down your site. This prevents from that, right? Someone who doesn't know what they're doing. Someone who does know what they're doing could actually do some work and get it to work. Yeah?
Do you have any suggestions as this gets more complicated for the QA department to be able to test stuff out? Like, what's your personal opinion on that? You just give them a client that you wrote yourself and that's what they test on? Or do you say, hey,
So my QA department, we do automated testing on most of it. Everything else uses our SDK, which generates an nonce every time. So we provide our QA department the ability to do this stuff. We also do load testing. The load testing gets very hard because you have to actually have way more clients than you are able to create requests because of the amount of, it's just the sheer amount of computing power necessary to interact with my API. We use just thousands of Docker containers, just trying to hammer this thing. But most places you're actually network bound. For my SDK, you're CPU bound. Because again, you're trying to make it difficult, right? Encryption, signatures, nonces, they all use up CPU power. And so you're costing people money, right? On the internet, when you're using something like AWS or Google or Microsoft or Azure, right? Network doesn't cost you. Outbound network doesn't cost you a penny. It's CPU that costs you. So you're trying to use up their CPU. Okay, so the next thing we do is we also wanted to do, where'd he go? Or am I in the wrong place? Nope, I'm in the right place. Okay, so the next thing we want to do is rate limiting. All right, so rate limiting requires you to identify who the user is and what they're doing and how many times they've done it. So the next thing we're going to do, man, just when you thought you were prepared. Okay, so the next thing we do is rate limiting. The first thing we do is we make a new signal. And so that signal is going to be the rate limit. Rate limiting. I want to make sure it at least matches up with what you might move forward to and not have a bunch of problems. Rate limiting signal handler, not tear. Limiting. I wasn't kidding about this typing stuff. And then we'll implement the abstracts. And this also, like we talked about, uses cache. All right, so we will need to pass into it a cache object. All right, and again, we're using base cache. Come on. right? So we have a cache. Let me move it up so people can see it and get rid of this so it's easier. Okay. So just like the other one, I mean, I guess I could create a base class for cache implementing with that. I hate using base classes for everything. So we have a rate limiting signal handler, and it's got a cache. So what we have to do is we need three things, right? We need a time period, be able to figure out a time slice because we're limiting per a period. We need to figure out who it is. And then the next thing we need to figure out is the count. You need to be able to add in the count. And so we're going to start by figuring out the time chunk. Right? So what I do is I figure out what time it is. Right? So that's what that gets us. And I'm going to convert that into an integer. So, whoops. Dot timestamp. So I got the current UTC time because it doesn't matter where the time is. I just need a value for what time it is now, and it should always be the same across any of my servers. So I've got that. And converting it to an integer, which it should already be anyway, but typing, that kind of stuff. And we're going to divide it by the rate seconds. So that also means I need to tell it how many seconds. All right, so we're add two things in here that I didn't add in before, so because I forgot. So rate count was an integer, and rate seconds in the constructor. So this way we can not hard code this stuff, because I hate hard coding things. So now we have a signal handler that will. The other thing you can do here as well is you can have multiple signal handlers, right? So I can say I can only do 10 per a second. I can do 100 in a minute. I can do 1,000 in an hour, right? So hopefully this thing allows you to do that, and we'll store these things. So come on, type. So we got that. And we've got rate seconds. So even though this is just kind of example code, you could actually use it whenever you wanted. So we've got our time chunk, which is the current time divided by the rate seconds, right? So that's going to, and it's it's going to return an integer, right? So it's going to be that value. So if you have a time, you divide it by 60, right? You're going to get the integer value of that divisor. So every time for that minute is always the same value. If you do it by 5 seconds, every time in that 5-second period is going to be the same value. It's a really simple equation to get you a slice. Again, we don't care if it's, for this particular type of thing, I don't care if it's 100, you know, if you did 100 in the 1 second beforehand, the 100 the next second after, I just want to keep you from doing 100 over 5 seconds because I'm trying to use the least amount of resources necessary to limit rates to what's acceptable. So when you do this, it really means that you can only, the maximum value across a span is double what your rate is going to be, because if they cross over 2 spans, they can have it twice, right? So that's something to think about if you're going to do it this way, is that if the most that your system could possibly handle was 10,000 a second, you want to limit it to 5,000 a second, because if they cross over that threshold during a second, then you want to make sure that you've not allowed them to hit your max. So now that we have our time chunk, we need our key. All right. So there's probably other ways to do it. I just do a simple string format. Which is going to be the path. West path, request method. Man, typing is bad today. And the time chunk. If you had user information, which we don't yet, you would enter user information here. So this is a global filter. Like no one can have more than this many. When authentication comes in, you could change that with an actual user coming in. We don't have that right now. But again, you would just add something to the key. You add another value in here, and you put a username in there, right? Whatever is going to uniquely identify a slice for an action for a period. And if you say you can only do this action, but there's like 4 different ways you could do it through 4 different methods, you have to find some way to devise what that is. But again, the other important thing is make sure these are happening in signals, because this is happening before it even gets to the router inside of Flask, right? So if you're going to do it for Django, make sure you do it in the middleware, right? Or in Pyramid, do it before you get to the middleware. Don't even process data in that request until you know you should be processing it. Stop it as soon as you possibly can. In Flask, without having to create you could do it with middleware in front of Werkzeug, but that's incredibly annoying and difficult to show. So that's something you could actually do. You could actually put an actual WSGI middleware in front of it and handle it there if you really, really, really want to get right in front of everything, but it's difficult to deploy as an application that way. Okay. And then once you've got the key, we want to try to you want to increment the key and determine if it's beyond what your rate count is, right? So you take your cache and you tell it to increment. So fortunately, in this particular cache implementation, you don't have to do the add and then increment. It just does the increment, make sure it's there, and it works. It does whatever it has to do for whatever implementation you're doing. So we're going to take our key, and we're going to increment the cache key because we don't care what the value is, and we're going to see if it's greater than our rate count. So we've got our unique identifier. We're going to increment the value. If it exceeds our acceptable value, we're going to error. And we're going to raise everyone's favorite, which is 429. There are oftentimes debates on what error number should be raised. My personal opinion is find a methodology that makes sense to you and be very consistent in your API. Try and go through the HTTP spec, find what error message makes sense for what you're trying to do, and raise it. That's a big REST conundrum, and it's almost a religious war when you talk to certain people. But we do 429 so that we can differentiate it from anything else. And that's it. So now it's going to see if you hit these things too often. All right, so if I go restart, that's a temp. Come on. There we go. So now if I go again, should be allowed. Oop, class terror. Where did I do that? Oh, I probably have to restart. Signals. I probably didn't, the server probably restarted before I got done. So let me go here and restart. Yeah. Not sure how that happened, but I'm not going to worry about it. All right. So now it's perfectly happy. Oh, it's going to be perfectly happy because I haven't added it to the server. Replay detect on that one. But what I have to do is I actually have to tell it to be used on the server. So we're going to go to server, and we're going to add in the rate limiting signal handler. import it, and it also needs cache. And it needs the number of the count, which we're going to say you can do 1 every 10 seconds. Right, so we made our new signal handler. The rate limiting signal handler, we give it the cache, we gave it the count, and the time. So every 10 seconds you can send one. And it has to be reasonable, but it has to actually be able to be aired. And then we're going to add it into our signal handlers. So now we have replay and rate limiting. So now, I should upgrade the client. So let me do that here. My client isn't keeping up. I know, on purpose, sorry. Because I'm adding the code, but my client isn't keeping up. So that actually gets weird. I hadn't thought about that. And since we're not changing that, we're going to add in replay prevention. Yeah. So you may want to, I hadn't thought about that. But you could, in theory, just copy the files anywhere you want. We're in replay, right? Rate limiting. Limiting, added. And then typing is unpleasant. Get another show. And then if I do the client, right, I didn't send any request. It was perfectly happy. I sent it again. It's rate limited because it's one within 10 seconds. Now I just have to wait for that 10-second thing to elapse. So let me change my clock. I don't want to get there. And now it should be fine because I'm another 10-second slice. I do it again. Still in the 10-second slice. Still in the 10-second slice. Still in the 10-second slice. But now it should be okay. Right? So it's a super simple operation to make sure that you don't exceed the maximum your system can allow. You can also, again, do it by user, and you may also need to do this again after authorization. So one of the things that we do is we limit by user, so we have a separate process, which is also in middleware, that once you've logged in, now I see how often you can hit it. Because depending on what your subscription level is, you might be able to hit it 1 time a minute, or you might be able to hit it 100 times a minute. So we actually add that in as well, but it's the same basic process, the same functionality. It's just user-based. Any questions on that one? Yeah, if you want to, yeah. So something I didn't think about when we're doing this, as you can move forward and stuff, is that the client changes to add things in. I thought that was clever. Originally, it just had everything in there and was more difficult. And you would have to turn things off because it wasn't expecting things to come a certain way. So I started automatically turning those off so you didn't see a bunch of data that didn't matter to you and that the thing wouldn't understand, which made it more difficult. So if you were to basically copy the directory somewhere else, the file system, check out the replay prevention branch or rate limiting branch, rate limiting added branch, then the client would actually work properly. My apologies for that mess up. I will fix that somehow. I'm not sure how. I may just have to have the same client put different configs, different things, so you can just change it really quickly. But so once you've done the copy, you've checked out the right thing, and you've done a pipenv shell to get Python running.
Git checkout a branch for a specific file too.
True, but then when you actually, if you want to move forward, it's going to get you messed up. Yeah. If you're a Git enthusiast, there are other ways to do it where you don't have to copy the directory. But for simplicity, yeah. But that's going to have to check the origin, and then you're going to have network connectivity. So I tried to make it so you couldn't do any network stuff. But you could also just do that exact same thing through curl if you wanted to. Just have to increment your piece there, because you'll get the Same thing. Where's the curl? I thought I had curl wing somewhere. Oh, there we go. No? All right. But yeah, if you did it with curl, it'd be the same thing. Stop caps. It's not in there. But once we get past this, curl's not going to work so great. So any other questions about the rate limiting? Or rate limiting, that one. Okay, so next thing is going to be, what is next? Let me look. Rate limiting, encryption. Encryption sounds difficult, all right? One of the advantages of JWE is it's not difficult. It's actually pretty simple. So the first thing you're going to need is an encryption signal handler. So we go back into our signal handlers. Interesting. Did not do that. Oh, yeah, sorry, you're right. Bad man. You think I've been doing Python programming long enough, I would know better. So this is just making me type less. And so it's going to need some stuff. Like all the things that we talked about, there are specific needs. Override methods, init. Okay. So in order to encrypt things, we're going to need keys. I've made this as simple as possible, so we are doing symmetric encryption. Symmetric encryption means you use the same key on both sides. That makes life easier in this example. It doesn't necessarily make it more secure. There are asymmetric methods available in JSON web encryption, and hopefully coming up very soon there will be some more modern stuff. But right now it's basically AES and RSA. And it actually has, if you don't understand cryptography, it's going to be way over your head. Don't worry about it. If you like cryptography, it actually provides a way for you to do RSA beyond the key size bound. By what it actually does is it uses an AES algorithm to encrypt the data. You select which algorithm to use. It then to do that, it generates a random key, an initialization vector, and encrypts that key in IV using RSA. So it's a really novel way to use RSA encryption, which is most cases more secure as long as you're using the correct padding, is more secure than AES, just because of key size and how hard it is to crack. But get beyond the 2048, or beyond the key size limitation, right? You can only encrypt things that are the same size or smaller than your key, and the closer you get to the key size, the less entropy you get, so you actually get worse encryption the larger you get. So they've actually gotten around that in a very novel manner. But we're just doing asymmetric key encryption, or symmetric key encryption, which is the same key. So we have to pass it a list of keys. So we have a list of key. And this is a JWK EST key, so we're using, that should actually be keys. So we're using this a library. That's what I use. It's not super handy. It does everything it should do in the most minimalist fashion possible. So if you want it to do nice stuff for you, you're in the wrong place. But it works and it's accurate, which is important. In encryption, not as big of a deal as it is when you start getting down to JSON web tokens. There are other libraries out there that will validate the JSON web token for you and do it in a sane manner without you having to write a bunch of code. This will not. But it does do JSON web tokens, JSON web signatures, and JSON web encryption, which is why I personally use it, because I use all three. So we want to make sure we store our keys. So we've got our keys. So in our request, we need to decrypt things if they're encrypted. So for me, the best way to do that is to determine it by content type. If you require encryption, you may want to do something different. And the making sure that it's Unicode is important, because a string going against Unicode is not equal. So make sure you use Unicode. So if the content type is, sorry, that should be application Jose, not JSON. If it's application Jose, that means the data is Jose encrypted. There's not a great MIME type, but that's the best one I could find for what I do, so I use application Jose. There's better ones for JSON Web Tokens, but we're not doing that. So if this is encrypted, I need to implement a JWE. Man. So that's the JSON Web Encryption instance. And then I need to decrypt the data. Not yet. Sorry. Yes, I do. Okay. Now this does something I'm not super happy about the way that it does it. And there may be a point where I care enough to actually do something about it. But what it's going to do is you just pass the keys, and it'll start decrypting the first one, second one, third one. So by the time, if you have a large list of keys, this could be computationally expensive using this library. If you can look at the data, which you can do, which we do on some of our pieces. I think we actually do that in a JSON Web Token. The key ID, if you do this right, will actually be in the header of the JSON Web Encryption, so you should be able to figure out which one it is and pass it in. But on this one, we're just passing in the raw keys and giving it that, and it's going to decrypt the data. And then we're going to do something naughty. Because Flask does not support middleware, I cannot send the next middleware a new request. Request is a global object that I now have to modify. It's ugly, it's painful, but it works. I will be talking to the main manager of this project this week to see if I can find a better way to do this. There was not one last year. I'm told you might be able to do this in a blueprint, but I don't want to have to get into blueprints. That's a fairly advanced concept for just using Flask as a thing to test with. But what I can do is I can say request dot, and their hair should be standing up on end because I'm asking cache data equals decrypted. And then, what's that? Yeah. Oh, I need to create the cache JSON first because it gets used twice. This was a change from Flask 0 dot to Flask 1 dot that broke my, that broke this presentation. JSON loads. Now you probably want to put more validation around that, but I'm not doing it at this point. This is just moving the data, and then it can be validated afterwards. And this requires a tuple of the exact same thing twice. I'm not sure why, it just does. Oh, cache JSON, sorry, not cache data. Yeah, so cache JSON requires the tuple of the two versions of cache JSON. I don't know why, it just does. I knew why. I looked at it when this was broken, when I upgraded to 1.0 or 1.x. Couldn't figure out why. And then I looked at it, I was like, oh, okay, I'll do that now. So basically what we've ended up doing is we take if the content type is encrypted, we then decrypt it using the keys. We then change the request to the unencrypted data. And then the next piece, oh, yes, sorry. That's why it's angry. It's not a method. Sorry. And then we're setting that. We don't need to, in other times you would, in other frameworks, you may have to set the content type to text JSON or application JSON. In Flask, you don't have to, so I'm not going to bother. Now, that's decrypting. Now we need to encrypt the responses. All right, so this is the first time we do a request finished handler. So after it's gone through your handler, right, or controller, or whatever you like to call it, it's gone through your route inside of Flask. You're going to get a response object, and then they're going to call the request finished handler on your signals. So the event is raised for that, which you get a copy of the response. And again, I can't make a new response and return it. I have to modify the existing response. Not my favorite way of doing it, but that's just how things work when you don't have real middleware. And there's no way to make real middleware. Okay, so first thing we want to do is make sure that it's not an error. So make sure that our status code, come on, is in the 200s, right? Because if it's not a 200 response, we don't want to actually encrypt it, because that's an error. And one way that people can take down your system is to send you a bunch of errors that you have to encrypt, right? Because encryption is a lot of CPU. So don't let people take your system down. We also need to make sure that we have content and that it's JSON. If we're returning text, we don't want to encrypt that. We just want to response content type. And response content type equals application. Application JSON. Because that's what Flask does. So Flask will return application JSON for JSON encoded data. Nope, response status code should be greater than or equal to 200 and less than 300. That's the first comparison. Doesn't need to be, because it's not actually it's not actually coming in from the internet. So, yeah, so this is saying that 200 is less than or equal to the response status code. It's basically an inline ternary operation. And the response in the status code is less than 300. So code is greater than or equal to 200, less than 300. That means it's a 200 status code. And if there is JSON data, we want to encrypt it. You know what? Let me do that so it's easier to see. Let's get all PEP 8, right? 80 characters. Okay. Yeah, so let's indent that one more. All right. So if this is a happy response, and the happy response is JSON, we want to encrypt it. So we want to get the response data. Get data. Get data. And we also want to make sure that we get it as text. We don't want it to be returned as a dictionary, because we want to encrypt the actual data. Okay, so that gives us our response data. We make a JWE instance. I understand this is really weird that to decrypt it, you pass it nothing. To encrypt it, you pass it a bunch of stuff. Not happy with the way PyJWK EST does objects, but it works. So it needs the data. We're going to give it an algorithm. So the algorithm is A256QW. So what this is saying is that it's AES 256 key wrap. So it's going to be key wrapped with RSA. And it's going to, A256 QW. And it's going to be key wrapping AES 256. So the next thing we have to give it is we have to give it encryption. What is it going to use to encrypt? And the encryption is going to be back up. This is not my code. It is using AES 256 key wrap. So I'm still using the key wrap stuff, but it's actually just AES encryption over AES encryption, just to make it easier. But I wanted to highlight the key wrap stuff. Sorry if I confused anyone. And so it's doing A256, the encryption is A256 CBC HS512. Now it could be A256 GCM. I think they even allow none for testing. And then the other thing that we need, or do we need anything else? And the content type. So one of the nice things about this, if you've ever used anything else for encryption and decryption, you're wondering like, great, I've got this encrypted data. What type of data is inside? So part of the actual specification is that you can provide the content type of the encrypted data. So it might be XML, it might be JSON, right? So if someone says, I want this data in JSON or I want this data in XML, you can return it either way and encrypt it and they'll know it's proper. So it's actually kind of a neat thing. And the content type is application JSON, because we know that we're encrypting JSON data. You care about Unicode where? So in the application JSON strings, you don't have to worry about Unicode because you're taking the string value that you've got and you're going to encrypt it. So it can be binary, it can be anything, it doesn't matter. It's just going to be encrypted. And when you decrypt it, it's not telling you what it's encrypted as, but JSON going across, I believe, I don't know if you can actually put Unicode data into JSON, but I'm not 100% sure. Actually, I know you can because our API accepts it. So that's something you would have to define what it's going to be as far as your character encoding, because the specification doesn't have character encoding. Although, if you wanted to, you could add it to the header yourself. It's a fairly simple task if that's something that you really needed. Our API just assumes it's UTF-8. Everything is UTF-8. Okay, so we have our encryption object, right? And then we're going to actually encrypt the data. Right, we're going to pass the keys. And we're going to pass it the key ID. So, which tells it which one to do. Since there are no specific IDs for keys, because these are all the same, we're just going to tell it to use the first key. So this is specifically telling it, I want you to encrypt using these keys, but here's the key ID for the keys. It always wants all the keys and tell it which one. If you don't tell it which one, it will select one. I don't remember which one, and because I don't remember which one, I'm always going to tell it which one it is. Because that's just the right way to do it. Okay, so the next thing we have to do, now I've encrypted our data. The next piece is going to be to modify the response. So response content type is now application Jose. And response data equals encrypted. A lot easier because it just allows you to do that stuff. And in theory, don't do that. This should work. So I need to add it to the server. I'll do that real quick. So you started off with a started handler. So if the application data is encrypted, I'm going to decrypt it and then replace the data inside the request so that when my handlers get it, it's decrypted. One of the super important things is that I learned from the API that I work on when I inherited it, is it did all the encryption and decryption inside the handlers with base handlers and things like that. And that can be problematic because how do you encrypt errors and there's a bunch of things that you have to take into account. So you're way better off. The other piece is in order to work on the handlers, you had to understand encryption. So you can't just have your average developer modifying your handlers because they're doing encryption, right? They're doing signature verification. That's a difficult thing. So you've now made it very difficult to use your handlers or to work on your handlers. So pulling it out into middleware, currently we're using Pyramid, where all that stuff happens in Pyramid middleware. Our controllers just go, oh, I've got data. I don't know if it was encrypted before. I don't know if it wasn't encrypted before. I return JSON data. I don't know if it's going to be encrypted or not. I don't care. So you have very simple handlers that any developer who builds a web app, who's used to building web APIs, can work with. And the difficult stuff is in your middleware that people don't even like to look at. But in reality, that's not a lot of code, right? That's 15 lines to inline, decrypt incoming data, and encrypt outgoing data. All right, if you've ever had to do this manually, this is a monstrosity of a process. If you didn't have a library that you could just have do it for you, especially since the fact that it's kind of come out in an interesting format. So if you take a look at what the response looks like. So currently you're just getting application JSON back, and you're getting back hello world. And what you're sending is you're sending content type application JSON, and it's decrypted. All right, so if I go add this to the server, I didn't want to do that. So now we go into our server, and we add our signal to our server. Actually, I'm not going to type anymore. I should learn from my mistakes. There we go. So we need an encryption. Oh, I'm in the wrong place. It needs to be before that. Encryption signal handler. Use encryption signal handler. Much easier. So the encryption signal handler needed some things, right? So it needs a key. And that key is a symmetric key, so it's something that's actually in here, so we're going to build it here. It actually needs a list of them, but we only have one anyway. So we're going to tell it we're using SymKey, which is a symmetric key. And its use is going to be encryption as opposed to a signature key. We're going to provide it a key ID for the first key. KID. We'll call it key 1. And then we'll provide the key. So this is just an RSA key. And since we're trying really hard, oh, it's going to make it. Yay, made it. You can copy it. So the key is it's long. The key is actually in the client as well. I think it has a default key here. There's your default key. So if you want to copy it from the client, you can do that, or you can type it, or you can get it from the GitHub repo on GitHub. But they're not supposed to be easy to remember. They're supposed to be random, right? So when you make keys, please make sure they're random, so no one can figure out what they are. All right, and the server's angry about something. What's it angry about? Oh, that's why. No, it should be fine. What is it angry about? Oh, okay. get rid of that. Okay. So we're just passing it in an array of keys. Probably not the cleanest way to specify an array of keys, but let me get rid of that so you can see it. All right. So we've got our encryption signal handler. It's got our list of keys, which are symmetric keys, getting passed to it. So we only have one. You can put in as many as you like, right? It doesn't matter. It's going to get the key information and decrypt it based on the key that it wants, or it's going to check each one, depending on which way it does it. So the idea for this is that you don't use symmetric key encryption because it's a terrible way to move things around unless these are internal APIs. But this is the simplest thing for me to show you, because if I had to have a RSA public key and have to explain how that stuff works, that would be more complicated. The reason that I did this is because it's easy to do. Symmetric key encryption is the easiest one for people to grasp. So I didn't want to have complex cryptography. So my suggestion would be don't do this. Use an RSA key wrap and use AES encryption in the back end. But this was easy to show. Okay. And then we're going to add it in, which is our encryption signal handler. And so now, when I send data unencrypted, actually what's it going to do now? Yeah, because I'm sending it unencrypted. Oh, angry. I didn't restart. I didn't have to. Encryption signal handler, name. I didn't? I am a terrible person. I thought I did. Yeah, it's up there. All right, well, you know what? Let me restart. This seems to happen, like it just randomly restarts while I'm typing things, then fails. So, nope. You did? Okay, I did something wrong. Ooh, it's so angry, so angry. So, sim key. My signals? Oh, I swapped it around. Oh, all right. Let me go back to my cheat sheet. Encryption. You're right. Yep, my bad. See, I can't read, let alone type. Yeah, so you should have gotten the key ID. Yeah, I tried to convert the, was it .kid? Yeah. So I tried to actually convert that to a string. My bad. So yeah, you want to tell it to encrypt the keys and give it the key ID so it gets the correct key. So this one actually, I think it's the signature where it does it either way. But this one's telling to encrypt, here's the keys, use this key ID. And then restart this because it's going to be angry. Client Pi. And -v. Oh, of course. Hold on. 1, 2, 3, 4. Oh man, I did it right at the beginning of the 10 seconds, didn't I? Okay. So what that did is I didn't send a request. It's a get. And so it sent this data. So this is Jose compact serialization. Its official name is base62 URL encoded. It's just like base64, except it doesn't have, it swaps out two of the things. You don't have plus, because plus is part of a URL, right? Because plus means space in an actual URL. And it doesn't have a dot, because a dot could be something that goes bad. Or no, sorry, it has no dot. What's the other one? Slash, sorry, because slash means another part of the path, right? So it doesn't have dot, or it doesn't have plus, doesn't have slash. So that's base62. Base64 has plus and slash. So it's super confusing, but you could actually you could use base 64 to decode it. The other thing that it doesn't have is it doesn't have any padding. So if you want to take a look at the data, if you're having problems, it may be a problem because it doesn't tell you if it needs padding or not. So that one needs padding. Nope, still needs padding. Base 64 encoding is really weird. I had to manually implement it. Okay, so here's all the information that you had. So it's sending across in the data. My algorithm is AES-256 key wrap. My content type is application JSON. My encryption is AES-256 CBC with an HS512 MAC. And I'll get into the MAC in just a second. And here's the key ID of the key that was used to encrypt the data. So all that gets sent across in the header. The data in the second set is going to be, I believe that's your key and your IV. Nope, can't do that. What's your binary? Oh yeah, key and your IV are binary. So basically what it ends up doing, the rest of the data, is you have your key ID, which is encrypted using the key wrap. You have, I'm sorry, it's the key, then the IV, and then you have your encrypted data, which is going to be there. And here, you're actually going to have an auth tag. So if more modern encryption includes auth tags, but this is an auth tag ensuring the header didn't get modified. So this is making sure that you know that based on the key that was supplied and the IV is actually separated into two pieces. The first half is used for the encryption, the second half is used for the auth tag. And so it basically creates a signature here, and that's what the 256, where is it going? Oh, it was in here, sorry. So when we had, here it is, A256 CBC's HS512. So this is telling you that the auth tag is in the HMAC with the SHA-512. So the fifth part is the auth tag. So this data is very secure. It hasn't been modified, except it could have been completely replaced. Now if I check out, is that right? Of course, typing. So now if we do the client, it'll also send the data encrypted. Right, so here it basically, here's the unencrypted body, and then here's the actual data that it sent. Right, so it said the content type was application Jose, which the server knows to decrypt. Here's all the encrypted data. The response came back with encrypted data, and here's the decrypted response. Right, so like 15 lines of code, transparent encryption on your API. That's why I love Jose. All right, this stuff we did in our controllers, part of our requests, like most APIs do. It was painful, it was terrible, difficult to debug, difficult to troubleshoot. Customers always had problems because in our SDK, like I would say at least 50% of our SDK code was around encryption and signatures. Now it's like 10 lines. It's amazing. And I hope I'm not gushing too much. But that's just like, this totally changed my life. Because again, this is very complicated stuff, right? We're doing encryption with key wrap and setting over your keys and the content type and all this type of stuff and adding an auth tag, which is the right thing to do in all occasions. And it was that much code. You have to make a couple decisions, right? What type of encryption algorithm do you want to use? What type of encryption algorithms do you want to allow? One of the things that we do is we actually take the encryption algorithm they send, verify that it's allowed, and then we'll respond back with the encryption algorithm that they used. So we allow RSA, V1 1.5, and OAEP. We shouldn't allow 1.5, but some of our clients have to have it because they don't have OAEP. we'll only respond with 1.5 if they give us 1.5 because that's not secure. But hey, if you want to be insecure, that's your problem. Right? So, but if you're smart or use the defaults, which we help make you smart, you're using OAAP as the padding, which doesn't have a padding oracle, at least a known one, and will respond back with just as much security as you gave us. So it's given us a lot of ability to provide the highest level of security with the most level of compatibility. So if you want compatibility, you get compatibility. If you want security, you get security. And that's a game changer for me. When you start dealing with banks and security companies and military, they all have a different idea on what's secure. And now they all kind of can get whatever they want. Any questions about the encryption stuff? Yeah.
I noticed on your signals.py that we're no longer inheriting the signal handler.
That one was just a mistake. I think I did it when I made it. It doesn't matter. Yeah, the signal handler just has a request started, request finished with, and it raises an error that hasn't been implemented. Because if you didn't have the request finish handler, it would actually error when it tried to execute it. So yeah, that was just, I'd fix that in the code when I do that. But yeah, when I actually built it here, I did. But I didn't put 2 lines between these, which is a PEP 8 no-no. Okay. The next part, I want to talk about more than type because it is a ton of typing. So the last thing that we talked about in authorization is using a single-use JSON Web Token. The PyJWK EST library does not make JSON Web Tokens easy. There's a lot of code. There doesn't have to be this much code, but there's a lot of code. There are other JWT libraries. If you're not doing encryption, I would say there are 2 other libraries. Find which one you like best. Because the PyJWK EST library is not an easy library to use. It's a good library if you understand how all this works. If you know what you need to validate inside of a JSON Web Token and you manually go through the process of doing that, it's perfectly fine. If you're just using JSON Web Tokens, try one of the others and see how you like it. There are 2 other libraries that I've used that are perfectly fine. We just don't want to have 2 libraries in our code. Okay, so what I'm going to do now is I'm going to hard reset. Am I in the right one? That's temp. All right. I'm going to get rid of all the stuff I spent all this time typing. And we're going to go to the end. And we're going to talk. Okay. And then in the wrong place, the right place there. I am in the wrong place there. In the wrong place here. So we will be in the right place and we will pfm shell. By the way, congratulations to all of you for making it this far so fast. Last time, this was like 2 minutes before the end of the presentation because we had a lot of setup problems. Maybe we should all say thank you to the death of Python 2.7. Regardless of what your opinions are on that, having only one major version is really nice. And for those of you who don't know, it's dead in December 31st. And I have a gigantic project to convert all of our 2.7 code to 3 that's going to take 3 months. Because it finally got fast enough. Okay, so we're in the right place. All right, so let's go look at code. So, should all be there? Okay. So this is a little more code. All right? But this is doing a lot of stuff. So at the very end, we talked about authorization using a single-use JSON Web Token. We talked about verifying and validating your request and your response. So what the token signal handler is going to do is it's going to ensure that the request coming in has not been modified and has been used by a valid user, and it's going to respond and create that same verification that the client can then use. So in JSON Web Tokens, there's this concept of leeway because it has time. And if you're dealing with servers that have time shift, which every server does, you want to make sure that you don't error out because you didn't allow for any time shift. When you said, this is only good from this time to this time, and what I will tell you is that a JSON Web Token for a single use should expire immediately because it's only good for one use. So you should expire it immediately, but allow for a few seconds, because if it takes half a millisecond and you're in or it takes a half a second for the response to go back, and you're now in a new second, your token's invalid because it's no longer, it's expired, right? So the concept of leeway comes in big with these tokens because you're dealing with time. So you need to provide a leeway in seconds. You need to provide keys, just like we did before. We're using the same thing. We're using AES. And we're providing cache. I don't remember why we're providing cache. We'll figure that out in a minute. Though the request JWT claims, so there's specific claims that are always going to be the same that you should be able to give. So the issuer, who's issuing the claim, is public, so that's coming from a user, and the audience is the example app, right? So the issuer, the person who's creating it, is coming, and the audience is the example app. So when we verify the incoming token, it should be coming from the public and specified for me, which is example app. Whatever identifiers you want to use, that's fine. We actually use, this is, like I said, this is a very simplified example. We actually have our user identifiers that say, I am this user, and that's the issuer. And when the response comes back, the issuer comes back from my API, and the audience is the issuer. You can also, one of the things that we do in my API is that you can provide authentication for another user. So we have hierarchical things. So if you're an organization that has multiple users, you can use organization credentials and say, hi, I'm this organization using my credentials for this user. That's kind of advanced. If you want to talk to me, talk about it later. And then the allowable hash algorithms. So we're going to be hashing the body to ensure it hasn't changed and putting it inside the JSON Web Token to be signed. It's not a necessary thing to do, but when we came up with this scheme, we said, great, we're going to use single-use JSON Web Token, and we're going to sign the request. What we found was, why are we signing two things, right? Because we were using JSON Web Signature for a header that had signature of the data, and then we had the credentials, but we couldn't make sure the credentials were actually part of the request either. So we decided that we're going to put the body hash and all of the request validation inside the JSON Web Token. So number one, we're only signing and hashing one thing. And number two, we can be absolutely sure that every piece that matters to us matches. So in the request started handler, the first thing we do is we get the authorization header just like we did before, and we default it to empty. And then we get a regular expression, and we try and find the header. So for this example, our authorization scheme is EXJWT, right? Example JWT. And the piece after the scheme should be our token. That's going to be our JWT token. We find it. If we don't find it, the token is none. Otherwise, we get the actual token value, right? So we make sure that the group dict, that we have a group dictionary. This is defaulting it to make sure we don't blow up. And then we get the token, or the key token. And so that's going to be our actual token value. Because the reason that you're using that is because we identified as token in there. You could actually just use place or whatever, it doesn't matter. If there's no token, then we raise a 401 saying that we're expecting a token. What are you doing? If we do get a token, we continue on and we verify our token. So we have our keys that we got, and we use JSON Web Signature to verify the compact JSON. So one thing about Jose is it's a bunch of things built on a bunch of other things. So a JSON Web Token is actually a JSON Web Signature where the body has a particular schema. That is all that it is. So if you've seen JWS somewhere, and people talking about JWTs, it's kind of like square rectangle. A JWT is a JWS, but a JWS is not necessarily a JWT. So we verify if we get an exception, then we do a 401 because you provided us invalid credentials. If the token itself is valid, which means that it's valid through the signature, I get the current time, and now I have to start going and verifying that things are correct. So we make sure that the client is correct. We make sure that the issuer, the audience is correct. I'm using JTI, so a JSON Web Token Identifier. That's supposed to be unique. And since we're using it one time, I provide that to create our nonce. So when we're doing our replay attack, this is our single thing that's going to be always different. You can make the same request for the same endpoint and the same parameters, all the same data. In theory, the signature should change from time to time because of the nonce, but the JTI is going to absolutely make sure it's going to be different every time. So that prevents replay. And then we're going to add the token ID to make sure that it's not there, right? So we're going to make sure that we haven't seen this JTI as we're processing the request to make sure we've never seen it before. That's why we're using cache. To make sure it's absolutely unique. And then we check to see that it's valid in the time space. So there's 3 times that you worry about. There's not before, issued at, and expires. So in here we're making sure that it's not before the not before, right? That's a claim. It's not valid before this time. Let's see if it's before that time. Making sure that it included expires and that the expires hasn't expired. And this one's not caring about when it was issued at, because issued at doesn't necessarily matter. So now we have pieces that are the extension. So we're extending JSON Web Token for our own purposes, and that is to add request data to the JSON Web Token to be signed. So we make sure the request is there, which is a dictionary because it's JSON, and so we make sure the path is in the request data, because every request has a path. We then verify that the path value inside of our JSON Web Token matches the actual path value, right? Because we talked about that. Let's make sure they haven't changed the method, haven't changed the path, haven't changed the body. The next piece is we go check and make sure that the method is inside the claims and that the claim method for the request matches the actual request method. If the request content length is not none and greater than 0, which means we have a body, then we make sure that the body hash algorithm is in the request claims. Because if there's a body, then we need a body hash to make sure the body hasn't been changed. We also need a body hash algorithm to know, right? Because we want to make sure that if people, for whatever reason, this particular machine actually works faster at SHA-256, they can do a SHA-256. Normal people can do a SHA-512, which is the things that we also specified in the top 2. So we have a body hash algorithm. We have a body hash. We actually go hash the body. So based on the algorithm they provided us, we update with the request data, which is the body itself. We get a digest of the actual the actual data, and then we assert that the value in the claim matches the actual body hash. So when you sent the request to me, you gave me a body hash that you stuck inside of the claims. I'm verifying that the data I got when I hash it, it matches the claims. So this is absolutely verifying that you did not change the method, you did not change the location, you also did not change the body. If there are other headers that matter to you, you could add those in as well, right? This is how we solve this problem. And again, it's a lot of typing. So if I got any errors, so one thing I'm doing is I just keep adding errors, because you can, one thing I found is when you have a valid web token and you get a response back, there could be 15 errors and people just hate it when I'm like, okay, I fixed that one, I've got that one, and you just keep going on. Especially in this particular scenario where it's a class and you want to find out what you did wrong. So basically it says if I got any errors, then I just join all the errors that were problematic and return a 401. I will be changing that because that's actually not correct. It's an invalid request. Because it's not, 401 says that you need to authenticate. Well, you did authenticate, and I verified that you authenticated. Your request is bad. So, should be doing a 400 there. And so that is how I verify you on an incoming request, right? So, again, this is a very simple one. You just provided a key and a key ID. And the issuer is the same. Right? In a normal situation with a normal application that was not an example that only had one user, right? The issuer of the request claim would be that user identifier, whatever that is for your user. And then they would sign the JSON Web Token using their secret, whether that's an RSA key, whether that's some kind of key that you generate, whatever that might be, right? Your API key. That's what they're going to sign it with, and you're going to verify the signature. So they're not passing any secret data. Super important. They're not passing any secret data. If your usernames are a problem, do what most API providers do and let them generate an API key, which is just random. It doesn't necessarily associate it with the user. Because that's going to be passed across clear text. Assume that all TLS is breakable and that anyone can see this data. So again, issuer is going to be their user identifier, and then you're going to verify that they are that user by verifying the signature that they created using their secret. Does anybody have any questions about that? I know signatures are a little advanced topic. Awesome. So response. Response is a little easier because you're just building stuff, not verifying stuff. So the first thing you want to do is make sure that this wasn't an error. And again, you may care if it's an error, right? If you return 301s, you're going to want to include that data. But it all depends on what you're doing. But for this particular one, we don't do any 301s, don't do any 302s. All we care about are 200 calls. So we're going to determine what the current time is, and we're going to start building a claims dictionary. So JTI, what I do, although we may change this, is another way to validate that the response you're getting is for the request that you made, is that you send over a unique value and you get that same unique value back in the response. This breaks caching. So we're actually going to have to stop doing this on certain calls because we don't want these calls to be cache busted all the time. So we're going to, on certain calls, we're actually not going to enforce that the JTIs return the same. Because if you make a call to, we have a call to go get the public key to start verifying our data, well, that public key never changes, and we want to be able to cache out on the edge that public key because everybody accesses it all the time. So this is one of those things, this JTI thing, returning the same JTI is going to break things. Now, one thing that you can do is you can, if you're going to do that, you can always just generate a random one when you ship it back. Just make sure you've never seen it before, right? Make sure someone is not replaying data to you in a man in the middle, right? So they can't just keep sending you the same response every time. Is this person logged in? Yes, this person's logged in. Is this person logged in? Yes, this person's logged in. Although your issued at and your expiration are going to help with that tremendously. So issued at is when you're issuing the token. Not everything checks for that. Not before is when it's valid. So it's valid. It's not valid before this time, and then expires at this time. So again, immediately expiring, because it's only valid for one call. And your leeway has to allow for the fact that it could take it a second, 2 seconds to get back, depending on where you're at. Right? We have customers that access our API from Australia, and sometimes it takes them a second and a half to get a response back. So they have to be able to deal with leeway. The issuer in the audience, which is basically the inversion of what you got the first time. The people who made the request are your audience going back, and the people they send it to is the new issuer. And then we add the response claim and add in the status code, the body hash algorithm, and then the body hash. I didn't add any of the header things like cache control, that type of stuff. This is just an example. But again, anything in the response that is important to you, that is important that doesn't change, you would add into this to ensure that it's signed and that you can validate it. So you create a new JWS with the claims and the algorithm, which is an HMAC SHA-256. You then sign using the compact JSON serialization, JSON web signature with the keys, and then you add the response header XJWT. So there is no authorization in response, so you have to put it in a header, some header. So in ours, we just put, actually ours is XIOV-JWT, in case anybody else is using XJWT. One thing you don't want to do, I made this mistake, is some things freak out when you put it in an authorization header. So you don't want to put it in the authorization header. This is not part of standard HTTP, so I would absolutely advise to use an extension header, use an X dash, so that nothing else tries to process it, because when you're returning this, nothing else is going to understand it. So don't make it think that it does. So now, on the client, yeah. This is going to be a lot of data now. Oh, and it's angry. Oh, so I don't have it running. That helps. Okay. So a lot of data. So when we make the request, we start off with our unencrypted body, right? We're sending over post data. We build our JWT claims. So here's our unique identifier, issued at, not before, expiration. The issuer and the audience, right? So the issuer is a valid client, audience is the API server. So here are our request things. We're saying the post, the method, and the path, the body hash algorithm, and the body hash. So the client has to do all this stuff, which is why my APIs are so hard. You need SDKs. It does all of this, ships it off. And the server receives it as a post, HTTP 1.1, content type application Jose, and here is authorization. All right? This giant thing here is a single header that includes a JSON web token. All right, so here's our authorization type. Again, don't use bearer. Even though it is a JSON web token, it's going to freak out because it doesn't understand who the issuer is. It doesn't have all this information it needs to properly handle this stuff. So you're going to have something special. And again, this is the same thing. Base62 URL encoded. You could use the Base64 decoder to decode it and take a look at it. That's a great way to do troubleshooting when things aren't working the way that you expect. But it has 3 segments, which are the header, which is, no, not in there. So the header has the key ID, the signature type, the algorithm used for the signature, and the fact that it's a JSON web token. And then you have the signature. Or I'm sorry, you have the body, which are your claims. So that's this. That's this data right here. This is that piece in there. So that's going to be Base62 URL encoded. And then the last piece is the actual signature. So this is HMAC SHA-256 or HMAC SHA-512. So it's always going to be the same size. And then the body is your encrypted data. So one of the things that we're actually doing is we're signing the encrypted data, right? Because that's the data that's in the actual body. We don't care if it's encrypted or not encrypted, right? So we're creating another transparent layer. I don't care what you're sending me. I just need to verify that it's what it's expected to be. So if it's unencrypted, I'm going to verify that it's correct when it's unencrypted. When it's encrypted, same thing. It doesn't care. It's just another layer around everything else. The response does the same thing. So content type, application Jose, and then here's our XJWT. So here's the signing of the data going back. And then here's the actual data. So it's encrypted data. And then here's the response claims that we verified. So it has the status code and the body hash, and it verified the body hash. Any questions? We've got like 6 minutes. This is super, super, super advanced, right? Your API may or may not need it. But if you do need things like this, or you have been adding signature data into your body, you may want to consider it because it made our APIs clean, easy. We reduced all of our roll your own crypto code. We separated authorization, or we combined authorization and data validation for the actual HTTP request, which made it actually easier for us so that we can verify all that information and a token that's signed using proper encryption that we didn't have to come up with ourselves. Yes?
Could this potentially be very useful for something like a microservice, where you're passing info from one service to another?
So the question was, could this be very useful for a microservice? That depends on how secure your microservice needs to be. Like I said, we don't use the symmetric encryption. We use the asymmetric encryption. But again, it can be used however you want to use it, and it can verify whatever data you need it to verify. So it's very extensible. Well, with that, remember though, microservices are expected to be very small and very fast. If you're encrypting and signing data, that's going to add some overhead. And how much data you're encrypting and what type of signatures you're doing can determines how much it's going to slow it down. So if you have a microservice that needs to be very secure, absolutely, but make sure you do some performance testing to make sure you're not getting CPU starved because you're doing all this crypto. Most systems out there have AES accelerators built into them. So if you're using AES encryption without the key wrap, you'd probably be safe. But then you also have to watch out because of key rotation and nonce collisions, and there's a bunch of crypto stuff you got to worry about. But if it's an internal service, the likelihood that you can rotate keys is probably very high. Again, the system allows for key rotation. So I would find something that works with what you're trying to do as far as speeds with microservices. I'd be wary of that. We do a lot of, on our systems, we do a ton of performance testing to make sure that as we're changing these things, because most applications in the real world APIs, your number one problem is not CPU, your number one problem is IO. Right? You're talking to microservices, you're talking to databases, you're talking to cache systems. That's where all your time is being spent. In a heavy crypto app, you start having to worry about how much CPU you have. Right? Everything can't be like a T1 micro. Right? You might have to actually have some CPU on that app server because you're doing a lot of crypto. Any other questions? All right, well, I only have one request, and that is, please rate this talk. It's a very long URL. Most phones nowadays support QR codes. That's a valid working QR code. It has no spyware. I just made it myself. To the lovely SurveyMonkey survey for this talk. I'm like super awesome, amazed and impressed that everybody made it through all the way. Way better than last year. And if you have any questions, I think the class thing will still be open. You can post it there. If you have questions about the stuff like you have the GitHub URL, do stuff there. I think my Twitter thing is really small. It's just my name with an underscore. Hit me up there or in one of the Slack rooms for Python around. I will be here all week, including all days of the sprints. If it's stuff you'd like to chat about. If you think doing stuff like this is something you might want to do, I will also be at the job fair, hint, hint. Not that I'm promoting anything, just telling you, I'll be at the job fair if you need to catch me there. Awesome, thank you.